Check.
Roger.
Not sure if there's a show today or not.
Yeah, I guess it's canceled, apparently.
Oh, all right. We had to cancel it because of you, Crit. Thanks, bro.
Yeah, I know. So rescheduled till tomorrow. Livestream's running though, so I watched
Yeah,
that.
yeah. Show's canceled. Geo lost power. Sorry, what were you saying, Crit?
I watched the new or the thing for the astronauts, the new class. Yeah, because every 2 years there's another 12 astronauts. So it was pretty hilarious. They like kept thanking God for this opportunity, and it's like each one gave a little speech. I mean, one had been like a weapons officer in the military. Another one worked in like offshore oil. They talked, and then it's another thing too. It's like of the 10 or of the 12, two will be from that going forward won't be Americans. There'll be two that will be foreigners, one man, one woman, and mostly from a non-Christian, non-Western country because they want religious diversity in NASA now. So not just one God. They want like all gods to be represented. And I was like, holy crap! How are the atheists going to square this, right? Because their big shtick is that NASA is like government, not government, atheist organization, and they did a whole prayer together. They had one of the congressmen, like Webb, talked about that he's working for a $5 billion supplement for NASA funding, and God willing, it will go through. And then they did a whole prayer together. So yeah, the show's live, but the live stream's up, but there won't be like the clipped like 2 hour live show with a format.
I'm here. I don't know if I'm coming through yet. Power. Yeah, I'm not even sure if it's coming through. Can you guys hear me?
You're
Real
super.
dim.
You're raw about it. Yeah, we can like barely make. You sound like Johnny Bernard if it was more. If Johnny was more coherent.
And apparently in science news too, like one of Musk's satellites, is Starlink, supposedly almost collided with the Chinese fake station. They had to do evasive maneuvers, and now they're pissed. And I'm like thinking, what's the point of that story, right? So, is it because Starlink is in trouble because it's not providing any service to people, and they want their money back. But Musk is like, all sales final, suckers, So then they're having to take him to court, but at the same time, it's like you know, now somehow they're too high, maybe because wouldn't the Chinese fake station be much higher than these supposedly Starlinks, or would it be low or something like that? Like It seems kind of rather off, right? Okay, so it says that their parking orbit, 270 miles. So whatever that means. Okay, and then let's see how the Chinese station. $264. So that's like 6 miles difference. Like a mid-air collision, right? So things 6 miles apart can also now collide with each other. See here, Elon Musk, SpaceX faces online backlash after Chinese report space station near miss. Close encounter between Musk and China result in internet showdown. This reminds me. You guys have seen the movie Night at the Roxbury?
Yeah, good movie. I can't talk right now though.
Oh, okay. Yeah. So in the movie Night at the Roxbury, the guy would just randomly blurt, "Did you touch my ass?" going down a fake station rabbit hole right now. Look at when the Mir crashed. Apparently, Australian fishermen recovered the wreckage and tried to sell it on eBay.
You guys fuck with crypto at all?
Not a lot, just a little bit.
No doubt. I've been thinking about starting up a phone mining thing here.
A phone mining thing?
They call it phone farm. It's where you have like a cell phone running and you get like, I don't know, 30 cents a day or something.
Okay, yeah.
And then if you get like 100 of them, my wife's going to love this one.
Get 100 phones, just have them all locked in a closet somewhere, chipping away at that crypto.
I'll have like a couple in my dresser, a couple on my computer desk, a couple, in the closet, one in the bathroom.
You also have like major cancer in every body part from all the radiation.
She goes to get her coffee in the morning. There's a phone in her coffee cup.
The temperature of your house is just permanently like 10 degrees hotter than everyone else around you.
Yeah, the feds rush us. They think I'm growing like poppy plants inside or something.
Yeah. Every time you use the microwave, the lights on the block go dim a little bit.
I'm blowing fuses and shit. Yeah. Phones don't really use like any electricity. Or not much, not compared to like a computer or something. I mean, 100 of them, then yeah, you're really talking something. But
What's up?
Hey, who's Conspiracy Santa again? I forgot already.
correct. Mine's the first thing to go, Brian. What's the date? Who's the president? Just fucking with you.
President 27th. Today's December Trump. You was on mute. What?
It's December Biden. The president's the 27th.
Oh, is that Mrs. Brian Leakey? Hello.
Yeah, that's right.
You have to excuse him. With 7 grandbabies and 6 kids, he gets a little mixed up every now and then.
Seen him do math?
Every night, dude. I'm always working on models and shit. Like I said, I had to brush up on all my shit now. So, yeah, I've got it. But I'm still learning, man. I'm brushing up on the calculus now, man. It's been so fucking long, dude. But yeah. Anybody can learn it, man. They make it sound like it's magical, mystical. Like they try and talk to you like you don't understand triangles or some shit, you know? If anybody give a fuck about triangles, then they go learn the fucking trig, you know?
I just want to tell everybody Merry Christmas and Happy New Year. I hope y'all had a good and safe Christmas, everybody.
Oh, yeah. Happy New Year.
Yeah, I did have some encounters though with math early on, admittingly. Um, like I had trouble, and looking into it, it wasn't really just me, but like when you think about when they say they call it 9.81 meters per second squared, but it's not really squared. It's 9.81 meters per second per second. If you square it, you're wrong, and that's what I thought it was. So that was one of them, and then I got into it with George or Rumpus or both of them. It took me a minute, dude. I had to stop and after the show on Brandon's, I had to go and look into this shit. Or I just could not conceive in my head that there's only like 10 or 12 foot or something difference in with a line on the globe or a straight line. I couldn't even. It just, there's nothing anybody could have said to convince me that there's only 10 foot of difference. And that changed a lot, man, as far as my way of thinking. Like, now I understand how they could easily confuse flat with globe. It wouldn't even have to be mistakes. Hold on a second. Anyway, my daughter's car alarm's going off. She ain't here. Well, that's aggravating shit. But anyway, so that woke me up to where, like, if it's only 10 foot difference between a curved line on their ball or a flat line, then that's outside of the margin of error, even, man. I mean, when you're measuring distance, you're talking, pulling a chain like they used to do. Now it's all now it's all dictated by the model pretty much, and it's probably more accurate now, but it's still outside of a margin of error, in my opinion. But 10 foot and 69 miles, you got to find a spot A to measure a dead straight line, and then even just elevation changes could easily add way more than 10 foot. But then when you start getting into like 2 degrees, like 140 miles, and then when the distance between it takes even longer than that, like to get any significant difference between a straight line and a curved line on their ball, you're talking 500 miles, and then you're so far you could model it however the fuck you wanted. Basically, what I'm getting at is
between the chord and an arc length, an arc segment.
Yeah, you can make it work. You could make it work any way you want it, man. They could easily, without lying or being dishonest, I could go out there and survey this fucker on a ball, even if it is flat, or vice versa. Just depending on how you modeled it, man. There's the only way to distinguish would be is if you could get accurate distances, like super accurate distances over large bodies of water, and that's wishful thinking at best. Anyway, that changed when I did the math, man. I was just like rubbing my eyes, like shaking my head, like, what? Like, dude, this is like, there's hardly any difference at all. And like I said, that opened up my mind to a lot, man. That changed my whole way of thinking, man. Like my Jeopardy board scrambling, like, but in a good way, though. That explains so much, man. It explains so much as far as with these surveyors and shit. They're just, stuck in their model, man, pretty much. But it trips me out when they talk about spherical excess. I was just listening to Charles Flat Earth Math. He looked into the spherical excess thing, and it was like some guys, like the 1800 surveys, like late 1800s, and it says
I
there
went
on
over
top
that
of the
one with
mountain.
him. Listen, I went over
Yeah.
that same one. They always use the same one. The thing with that measurement is, if you look at the numbers, they're 3 digits past the decimal point, which is that's not even possible to accurate. The only reason why they have those 3 digits after the decimal point of how many degrees it was is because you got
Arc seconds.
echo.
Oh, sorry, arc seconds, man. But yeah, I just found out, Jeremy, that refraction is included in that measurement. To top
No,
it
they
all
say
off.
there's no left to right measurements.
But the whole thing is that I brought this up on Brandon's, and he kind of emphasized it. Like, if you have line of sight, you can't have excess if you have line of sight. It's goddamn ridiculous, right?
Well, no, that's why it's a left to right. Yeah, I don't know about that. Anyways, the whole thing with that is they don't even have a measurement. All they have is an average. Remember, I was bugging for a while about averages and measurements not being measurements. That's why that measurement, that average, they don't even have. They're like, what do you need the measurements for? I'm like, I don't know. What if your boy fucking did the average wrong? You know, math mistakes happen. Like, let's see the numbers so we can see if he did the average right. We don't even know if he did the average right. So
That's
they don't have. That's not a measurement, dude. 3 digits past the arc second. Measure that. The only reason they have those 3 digits there past the decimal point is because it's an average. You couldn't. That's not an actual measurement. Those numbers they give.
Yeah, no, I'm at 3 digits past the degrees starts getting in arc seconds and shit. But yeah, no, yeah. I was gonna say, but my point would be is if you have line of sight, you can't have excess. If you're gonna draw your excess like sideways, then if you get that shape in real life, you're gonna have 2 tangents on each side. So that would be a 6-sided triangle. I'd have to draw it to show you, but that's the only way to do it is to have 2 tangents on each side.
6-sided triangle right now.
Yeah, that'd be crazy. But other way to do it. But anyway, he just looked into it into detail and said that he justified it with them arc seconds or whatever with refraction. But it's over from like 3 mountaintops, and the guy stayed up there for like. They stayed up there for like a couple weeks or something for everybody to get set up. I think the guy who got there first, whatever, was up there, trying to keep a fire going and shit to stay warm while the other fuckers got up there to measure lights over like a long distance. I forgot exactly how long, but it was way too far to try and make any kind of accurate measurement. But it all included refraction. It was all model afflicted. It was all model biased. Right out of the gate. But yeah, that's a good point with averages. That kind of shuts it down without even getting into all that, right?
Yeah, dude, there's no measurement there to even look at. Like, they don't even have a measurement for that spherical excess thing. I brought it to Bev one day. Shout outs to Bev, and Bev was like, well, why is it, he's wondering why it's 3 digits past the arc second or whatever. Because that's like an impossible fucking, you know what I mean? Like, even the highest tech ones of today, if you had 3 digits past the arc second, you're basically just guessing at that point. You know what I mean?
Yeah.
And they were using shit from the 1800s, so they weren't getting nowhere near as close as we are now.
That's just it. Today we got better tools, better technology, and as far as the today debate, I mean, I have to say that
and
we're
shit's
winning
wavy, bro.
Debate.
Even if they could get the Crosshairs line up over 100. These were 100 miles. Some of them. You know, wavy
Yeah,
shit's
exactly.
gonna look.
Yeah,
It's
that's
gonna
crazy.
be if you're looking at something at 100 miles, you're guessing on where the crosshair even is at that point. 100 miles away and see if it ain't wavy. You could look at something enough day. You could look at something, the car in front of you, and it'll be wavy.
Yeah, it was like a long way. Now that you mention it, man, I remember that
Dude,
that
100
kills it right
miles,
there.
bro.
Oh man, I
100
looked into.
miles.
I found that thing I was looking for the other day as far as the Alberuni that they did. It was the main surveyor, I believe, and so I'm trying to get hold of him. He's disappeared. Jesse Kozlowski has disappeared. Trying to get somebody to discuss this because, yeah, it was 27 million feet is what he come up with for his Alberuni measurement when the radius of their Earth is like 19 between 19 and 20,000 feet, and I mean million, 19 and 20 million feet, and his measurements averaged out, so they bounced up and down within a couple arc minutes, probably like about from 8 to 10 arc minutes. It fluctuated, which is decent. That's a decent amount over miles and miles. But the point is he was off by like 30% before the refraction. And then if you want to look at it like if he just was to do it off of 1 or 2 days measurement, he could have been off like by 50%. Like by averaging it, he got a little bit closer, I guess, to what he was looking for. But the point is he's looking for like a little under 20,000, 20 million feet. It's like almost 20 million. I could call it 19 is kind of cheesy. It's closer to 20 million. But so that got him. But basically, so he's off by 7 million feet. Does the refraction, then he's only off by like 500,000 feet, which makes it within a couple percent or something. He's off by like 250,000 feet in the end. So he's off by 250,000 feet, and that's acceptable. That's within like 2% of the accepted radius. It's like a big joke, man. Just talking about it is making me laugh, and I'm the one talking.
Yo, Jeremy, what'd you think of my Sextivis?
I didn't see it.
Oh my god.
You're what? You're what?
My Sextivis. It's a two-parter. I haven't finished my Sextivis, the physical one yet, but I'm gonna use it to make elevation angles. Anyways, and then I made a bot that when I put in the elevation angles to whatever stars or whatever, it'll plot my position possibly, and it works. So I put in 3 stars and 3 elevation angles. It says I'm in Austin, Texas.
Is that for local or just like one point in time or what?
It's for any single point in time, but it's it uses the entire Earth.
That's what I was gonna say, man. If you know everything, and you don't even hardly need a sextant if you're gonna go off these exact measurements. If you know that you got certain amount of miles per degree, and you know that the angle's good anywhere on Earth, then you shouldn't even need a fucking sextant hardly. Maybe just
So
really all you need is a compass,
You still
as
need the
a
sextant.
plumb bob, and a damn compass. I mean, not a compass, but a protractor, right?
Well, the sextant is to take the measurement, of the angle.
Yeah, but point being, you wouldn't even need nothing that fancy, or with all the mirrors and all that shit. All you need is a fucking protractor, right?
Oh, my Sextivis is you'll see. It's not that much more sophisticated than what you just described, actually. But For the bot though, I got it to pull the data from the almanac, and it'll just plot it on the Earth. Pretty cool stuff.
Here's the thing, though, man. What I was saying, as far as them talking about not using the horizon or using bubble sextants and all that, like I'm calling semi bullshit on that, at least, because when we're using a bubble, we'll use it for accuracy up to about, if it means something, like if we're going to build on what we're pouring, like maybe up to 20 feet, we'll use maybe a bubble level or spirit level. But if it's something long distance, man, you need an auto level to get any kind of accuracy. Like if it's like a couple 100 feet, you're not going to use a bubble level if you need precision, because unless you just run if you keep running the spirit level down the board, move it multiple spots. But as far as one spot goes, you're not going to get any kind of accuracy for a baseline within a couple 100 feet. If you're talking about multiple miles, a bubble sextant is more or less just a guess.
Yeah, you're not using it over any distance whatsoever. You're just simply using it to measure an angle. So I think it works infinitely. And that you're not using it to measure a distance.
That's just it, man. It's if basically the baseline, if your bubble is off by a fucking speck, something the human eye couldn't even see, the distances you're talking about, it'd be off a lot, dude. A lot more. Sure, it would.
If it's off by an arc second, for example, or an arc minute, for example, your measurement's going to be off by a mile. Not that much, but that's of course, if you're off by an arc minute, which if you make it level, there's no reason for it to be off by anything.
I think you're missing my point.
Setup that you described with the protractor and the whatever else you're going to use, like let's say the hanging plumb bob, right? If you had it so that the plumb bob was hanging perfectly, the string was thin, and you measure up to whatever star you're looking at, I mean, as long as the ticks on the protractor can get within fractions of a degree, you're gonna get a pretty sound measurement, right?
Yeah, but if your star is 50 trillion miles away, and you're off by an arc second, you're off, dude. You're off by a quarter of the planet, dude.
I don't think that's relevant though. That distance you're talking about and that measurement.
Right. Height is not relevant. That's exactly what the fuck I'm trying to tell them when they're talking about our height of fucking Polaris. When we're talking about using a sextant, that's my whole point. Height is not even factored in. That's why I said if you're gonna pin us down for fucking height, then we're gonna have to pin you down too, and then you're gonna have to explain the light years. So yeah, it's not a factor in either fucking model. For use of a sextant, it's a non-factor.
The argument doesn't really work in reverse though, because in our model the distances aren't really relevant, but in your model the distances are a result of them being close and local. It's a result of the angle.
Listen, bro, they had to go to each one of them spots they plotted. They plotted substellar points for each star you see in the almanac. It took years. They didn't just use the math, dude, in the model. Or if that's the case, Kosho, they could have just did one star, per section maybe, and just plotted every other star. They could have plotted every one of them. No, they used substellar points. It took years for them to time it all out, and they're not going by the model like you think they are. So that's why the height is irrelevant.
It's like you're having a totally different argument all of a sudden. I never said any of this.
I'm going into detail. It's irrelevant. The height is irrelevant when using a sextant.
Yeah, of course it is. That's what I was saying before. The height is irrelevant.
It's only relevant on a globe Earth, though. That's what Kosha was trying to say. On a flat Earth, you need that height to be small enough that you can create these angular changes over short horizontal distances, because that's how triangles work.
Right.
right? Because think about it. If let's say the object was 900 feet above the, or 900 miles above the flat Earth, then that means that if you went 900 miles away, you would expect it to be at a 45-degree angle, right? Because if you have a triangle where the base and the height is 900 and 900, then it would be 45 degrees. That's why it has to be close. Otherwise, if it was as far as the globe earthers claim, right? And once you get past, a certain distance, it doesn't matter whether it's 100 million miles or 100 trillion miles. No amount of small horizontal movement would change that angle at all. It would be, if that was the same height over a flat Earth, then for every location on the flat Earth, the star would be directly overhead. If we're talking about like Polaris, for example, it wouldn't matter where you are on the flat Earth. Polaris would always be right above you if it was, trillions of miles away. The fact that Polaris moves so quickly, 1 degree every 69 miles, or every 1 degree every 60 nautical miles, means that Polaris would have to be close. And then the problem that you run into is, once you establish a distance, any distance that you set, the math doesn't work on the math of triangles don't work, because it's only right for 2 locations, and it's no longer right anymore.
I concur. Hey Jake, what do you think of my Sextivus, man?
I don't know what that is.
What?
No one knows about this half-ass thing you made out of cardboard, probably.
What? You guys are jerks, man. 100%.
Wait, no.
You said the Sextivus. Oh, go ahead, Brian.
I'm sorry to interrupt. I was just trying to see, Coach, do you got a channel?
I mean, I have like 1,000 channels, but I didn't
check his website. I love gayporndudes.net.
Actually, I have a website called sextivus.live.
Oh, why don't you post it? Post me a link and to that thing you're talking about.
It's not on the website yet, but it's in Jem's server. And I mean, it's in my server too. It's in every server that my bot's in. But I mean, I posted a picture in the chat of the outcome. One more picture. That was on a globe, the picture I posted.
Yeah, basically you've projected the spherical, the heavens, the celestial sphere onto the ground, right? Basically.
Yeah, but check this out. When I do it on the flat Earth, it doesn't give me the correct location.
I bet you're using longitude. You're using longitude, ain't you, Coach?
No, I'm using celestial navigation.
Did you use my equation?
No.
To do the corrections? Well, there you go, man. You fucked up.
Well, I got the right answer. I got the right answer on the globe, though.
Yeah, because you're projecting the sphere. You're projecting the sphere onto your ground. Okay, from using a spherical projection. Everything, the map you're using is a spherical projection, bro. Of course, it's gonna fucking work.
It's incorrect.
So what you're trying to do? Hold on. You're trying to map a spherical, celestial dome, basically celestial sphere, onto a flat ground using spherical coordinates. How could that couldn't possibly work?
Right.
You even tried it. It's an insult to us that you even tried it and mentioned it. It's like an insult.
Just to clue you into what actually I did was all I did was take the instructions from making a celestial measurement using the 3 stars and 3 elevation angles from those stars for my position. That's all I did. and I did. I used the almanac.
I know, but
I used the almanac. Hold on. All I did was use the almanac, and all I did was make circles of equal altitude, and I plotted them on either of these maps. Those circles of equal altitudes, one's plotted on a globe, one's plotted on an AE map, and that's all I did.
The challenge, though, is to plot it on an actual globe. Get an actual globe and plot them.
That's what I did. That's the top one.
But my other point is I've explained this to you enough times to where if you're using like Mercator or spherical projections, okay, if you're using AE map, azimuthal equidistant, if you're using spherical projections, it can't possibly work. That's not a flat Earth map. You need to get the Navy grid almanac, the grid map. Okay, that's gonna be way more accurate than what you got. If you use the Navy or the Air Force their grid map, and you're gonna get way more accuracy than what you got on your spherical bullshit. And you say you plotted it on an actual sphere?
The Air Force doesn't have a global grid map.
Yeah, they do. Or the Navy. The Air Force is a branch. Hold on.
Yes,
the Air Force is a branch of the Navy.
No, it's not.
The Air Force is a branch of the Army.
It's well, it used to be.
It used to be.
Army, but
Yeah, it's a separate branch now, but it was originally part of the Army Air Corps.
it was never part of the Navy.
Sorry about that.
Space Force is a branch of the Air Force now, just like the Marines is a branch of the Navy.
Okay, so Marines is the branch of the Navy. I got you.
Correct, Mondo.
Yeah, I'd like to take a look at it though, man. I really would, man. I dig shit like that, man. I think Bev would say I'm model afflicted. No matter what model it is, I like the modeling and all that. Fucking so I'm model afflicted, man.
How do you determine on the flat Earth? How do you determine your distance to the GP from your angle measure on the flat Earth?
With the almanac.
The almanac only tells you where the GP is. How do you determine how far away you are from the GP? Once you have the location of that GP and you have your angle, how do you determine how far away you are from the GP on a flat Earth?
Instead of going through this all over again, I'm just going to post a little video. And right now, I got to take a break anyway, just for a minute, but I will be back if you're interested in talking. But I'm going to post a video instead of going over this all over again. I'm just going to post a little video, and you can kind of sift through it a little bit for key information.
Is this Globus's video? Have you seen this video, Kasha?
No, I haven't. I heard him argue with it before though, so
I'm willing to bet it's not going to explain it.
I'll take that bet, and I'll also bet whoever.
I haven't seen any flat earther explain how you determine your distance to the GP on the flat Earth.
Well, I'll tell you this much. Brian did a very I can't remember or recall any of it, but he did try to explain it the other night. It's probably in this video actually.
from that zenith to determine locations. Everything probably circles look okay.
He said in there that the almanac will tell you your distance to the GP, which is a lie.
Said what?
That
You
was
said
lie
what?
number. He said in the video that to determine your distance to the GP, you look it up in the almanac, and that's a lie.
Yeah. Also,
then they would have to have every possible location on the Earth in the almanac for that to be the case.
You look up your angle. Listen, you look up your angle, you get the distance. Okay, it's 69, roughly 60 nautical miles per degree. Okay,
Yeah,
we know
that
that.
that doesn't work on flat Earth, though. That's the whole problem
Yes, it
here.
does.
That only makes sense on a globe. It does not work on a flat Earth. There is no triangle that you can draw on a flat Earth where you'll have 1 degree of change for a fixed distance. That doesn't work on any triangle. There is no triangle that works that way.
You're not using refraction. Shut up,
Huh?
dude. Quit yelling.
What?
You're not using the refraction, are you? You're not using refraction, are you?
No, you don't even have to
Okay,
take.
what I want you to
You
do.
don't have to take into account refraction for this. How would you apply the refraction?
Why don't you do on a flat Earth? You do on a flat Earth.
So on a flat Earth, the refraction would be the same whether the object is 5 degrees above the horizon or 45 degrees above the horizon. You'd apply the same refraction.
The refraction's it's a minus 90 over 90 times distance times point A. So you hear that? You catch that? That's the refraction for a flat Earth, okay? Because there's a celestial
8 minus 90.
sphere.
Okay, so let's do the
There's
example.
a celestial sphere. Yeah, do it.
Okay, so we're so let's say that the object is, let's say our angle is 45 degrees. Okay.
All right, let's do.
How do we know our distance to the GP? How do we know our distance to the GP?
You got to measure an angle first. So you're out there.
I just said 45 degrees. If the angle is 45 degrees, how do we know what the distance of the GP is?
You got to do the triangulation and get the distance, and then on a flat Earth.
Okay, so if we're gonna do the triangle,
let me answer your question, bro. You asked me a question, you don't let me answer.
Well, I don't want you to go too far because I need to break it down into steps.
I'm not going
and if
too
you
far.
keep going, then we can't go through the steps.
I'm finishing one sentence, bro. One sentence. Okay. You get the angle that you measured, and you take it and you triangulate it on a flat Earth, and then plug in the equation.
Okay. The angle that I just measured is 45 degrees. How do I know my distance to the GP? Go through the first step. What's the first step that we do?
Triangulate it.
Okay, how do we triangulate it? What does that mean? What do I do?
Dude, if you can't triangulate what fucking 45 degrees is, okay, the first step is that we're going to measure 1 degree, okay? So we don't know if we're standing on a globe or a flat Earth. First thing you got to do is go 69.1 miles, we'll call it, and see how much the degrees the star change, okay? It changed 1 degree. So now at this point, is it the ground curving or the light curving? Either way, we know that that height triangulates out to 3958.7. Funny, it's the same as your radius, ain't it? What a fucking coincidence. But anyway, 1 degree triangulates out at 3958, we'll just call it, for rounding it off, 3958. All right, so now, whatever measure, so if we're out at sea, and we'll just do, I like to do 30 and 60. And we take an angle reading, whatever angle we measure, we then, you can plug it in the triangle calculator. So 3958 for your height, and then whatever angle you measured, okay? And then what distance you get, you plug that in. So 90 minus 30 would be 60. So 60 divided by 90 times 2855, it works out for the triangulation. So basically, so 90 minus 60, 90 minus 30, so 60 is 60 divided by 90 times 2855 times 0.60 is, I think it's 100 and something, but whatever it is, it works out to the dot. and then I do 60 degrees, and so I say 90 minus 60 is 30. So 30 divided by 90 times 6,855, because it's a long way. It does triangulate out a long way. So it's a lot more refraction with an angle that steep, you know. So 30 divided by 90 times 6,855 times 0.30. That's your refracted amount. Subtract that from the 6855. That's your true distance, and it comes out to 69 miles per degree.
Yeah, the reason why they say it can't work on a flat Earth is because they have a lot of assumptions on how the sky is working. So, yeah, in their model, it can't work on a flat Earth, of course.
Yeah. So I want to know how they got that radius to begin with, because when you do the fucking math, you get 3958.7 to the star above you, not from the center of the Earth.
Oh, hold on.
Feet, your feet.
So you said, so hold on. We're gonna go through this together, okay? So you said we take a triangle and we do it at 1 degree, okay? At 1 degree, you're saying that the height of the star above that location is 3950, right? Or 3959. What did you say? You say 3950? What do we use for the height for the star of the triangle? The height of the triangle is
Yeah, so
3950.
say 90 minus 1. Go 90 minus 1 is 89 degrees. So
Right.
plug in 89 degrees on for your angle, and then plug in 69.1 for B, side B, for your length.
You mean, well, then you would mean 1 degree.
Yeah, 90 minus 1. So we're gonna.
Well, no. You would use one for that. You would use 1 degree. You wouldn't.
Not if we're using fucking latitude, dude. I got to go through this with every single person. Okay, if you do 1 degree, bro, if you on whatever model, do you think you're going to be 69 miles if you're at 1 degree latitude? Are you going to be 69 miles away from the fucking North Pole?
Okay, I got it. Okay, all right. I got it. Okay. So then at 45 degrees, so now we'll change that triangle using that same height. We'll change that to 45 degrees, right?
Yeah, no. Yeah. Now you go 45, yeah. With 45 for your angle, and then 3958 for your height.
And then that would give you 3950, right?
Should give you like 3958, basically. So now, what you do is you
right, but when we multiply 69 times 45,
no, you're not doing
that's
that.
31. That's 31. Well, you just said it's 69.
Right?
You said it's 69 miles per degree, right?
Yeah, you got to plug in the equation. Okay, so 90 minus 45 is 45. So 45 divided by 90. Okay, work with me. 45 divided by 90. You got a calculator in front of you?
45 divided by 90 is half.
0.5. Yeah, it's 0.5.
Okay, times 3958.
Half of 3958.
Okay,
It'd be like
1979.
45. Okay, times 0.45.
Times 2,000 times 0.45. What?
That's 890.
Oh, man. Let's just start over. Okay, 45 divided by 90.
That's half.
Times.
Yeah.
3958 times 0.45. That's your
That's 890. Amount. The answer to that is 890.
Okay, now subtract 890 from the 3958.
So roughly 1,000 from roughly 4,000. That's roughly 3,000.
Hold on, let it go. Okay, now divide that by 45. That's how many miles per degree it is.
The 69 miles per degree is from the center of the Earth. So you can't really go past 45 degrees. Otherwise, you're going to double back.
Don't
You
dump
can't
on
really
my
go
model.
past really 90 degrees because from 0 to 90, you basically double back on the circle.
Lemon, you dump it on my model.
So the 69 miles per degree
Okay,
meets
but
that
that,
baseline.
what you're essentially doing is you're still getting to 1 mile you're 1 degree per 69 miles by doing that whole thing, as opposed to we're not taking the tangent of a triangle, which is what we would be doing if we're talking about a triangle.
Look, 69 miles per degree times
What I'm
gives you
using
the
is a
whole
ratio.
circumference of the Earth.
What I'm
So
using is
if you go past 90 degrees, you're doubling back. So you would be going forward from 0 to 90, but you would start going backward if you go past 90 degrees, effectively going in a negative direction. So you would go, a fourth of that circumference around when it's 90 times 69 miles per degree, and then it would be negative. It would negate that 90 times 69 miles per degree if you go past 90 to 180. It would go back to 0 because you'd just be directly under the initial position on the other side of the Earth.
Excuse me for 1 second, Lemon. We were right in the middle of he was testing my model, but it worked, right? On a flat Earth, you got 69 miles, correct? Anyway, the answer is yes, it did work. The equation is 90 minus A. A is the angle you measure. 90 minus A over 90 times D, which is the triangulated distance, times point A. So 90 minus A over 90 times D times point A. That's simple. That's a refraction on a flat Earth. But really, in my model, I got it from the equator to the North Pole at 60. At 6,170, which is a little bit less. So, I got mine coming out to like not quite 69.1. It's like right on it.
Wow.
It's not far enough off for them to make any kind of complaint.
How big does that make your equator?
Well, it's not. I'm not using a elliptical or what do you call it? Ellipsoid.
Area of a circle. I mean, the circumference of a circle.
Yeah, I'm not using a pear shape. We'll say.
You don't have to use a pear shape. I'm just saying because you have that distance from the equator to the North Pole. I'm just wondering how big that makes
I took a picture of my feet, dude. Did the math. I did the math for the distance of the Tropic of Capricorn.
Sure.
And
how big does that make your equator though? Like, what's the circumference?
I got it written down, man. I have to go look. I'll post my sheet for you. I'll post a picture of it.
Well, I mean, I think I can tell you what it is.
69 miles times 300. What was that?
38,500 miles around.
But basically, man, it's just a refraction model based on distance, based on the ratio of the angle compared to the distance. So the ratio of the basically like I said, the refraction is it's a ratio of the angle times the distance, basically. Is what it boils down to if you want to try and shorten it.
You're just going a long about way of basically multiplying the angle by 69 miles per degree.
No, I'm not. No, I'm not. What are you talking about? No, I'm not.
Can you do this measurement?
If I was going to do that, I'd have had to multiply everything times 69 to have the least common denominator, and that would have been fucking cheesy as fuck.
Can you walk me
I didn't do that.
Can you walk me through this from an elevation angle of 89 miles? I mean, 89 degrees, I mean.
Yeah, can you give me just a few minutes. This fucking horn's honking again. Give me just a few minutes if you're still here. Yeah, I'll walk you right through. Hey, in the meanwhile, Kosho, do 6170. 6170, just do 30 degrees and 60 degrees. What the distance would be like on a ball for that. And see. So we'll have something matching up to it.
I know what it is. I'm trying to see what the calculation for 89 degrees is.
It's close, man.
You understand that when we're talking about triangles, we're talking about and we're trying to determine angles corresponding to sides of a triangle, you're talking about tangent, sine, and cosine, right?
I'm not using tangents or cosine. I'm not. Listen, I'm just using the ratio of the side. Okay, the
Right, and
ratio. I mean, the ratio.
any fixed ratio.
The ratio of the angle. It's just the ratio of the angle. No more, no less.
Yeah, and the ratio will only work on a sphere because on a sphere, every angle corresponds
I just did
to
all
a
that.
fixed
And
distance.
still talking about it only works on a sphere.
It
Bro,
does only work on a sphere.
No, it
That's the
doesn't work on
problem
your
because
sphere.
you don't understand.
No. Let me
When you
tell you
take a
why it doesn't.
triangle and you set any object, if you set any object over a given height on the flat Earth, and you calculate that triangle, you will never get a fixed ratio of distance to angle.
Good. Let's triangulate Polaris in your model then, okay? Let me walk you through your model, okay? So what's the height to Polaris? So we're gonna go 1 mile, okay? I mean, we're gonna go
trillions of miles away.
Don't try to skip it, though. We're gonna do your model. Let's triangulate Polaris.
Work in our model.
Let's use triangulation, okay? And we're gonna triangulate the Polaris. We're gonna go 69 miles, okay?
We don't
and we're
claim
gonna
that
measure.
works in our model, man. It doesn't work.
Well, he's sitting there claiming
it works in your model. It does work though. And
yeah, because we're not talking about triangles. That angle is changing because the surface that you're on has changed. The angle of the surface that you're on.
The triangulation that you use for Polaris assumes that the Earth moves millions of miles in space over the period of 6 months for any sort of triangulation. You need a large enough distance for the triangulation to be worth it, not just the surface of the Earth. It's with a different baseline. It's the baseline of the Earth moving millions of miles through space for like the bottom leg of the triangle. So it's a different baseline.
Well, that's if you're trying to parallax. If you're trying to use parallax to determine the distance to the star, yes, that's how you would do it. You would.
So you can't just use the surface of the Earth. You have to use a different baseline because the distances
are talking about. We're talking about determining your distance on a location on the Earth from the star GP.
So I'm talking about the problems with trying to triangulate Polaris using only the distances over the surface of the Earth. You need to assume that the Earth moves millions of miles through space to get a baseline for your triangle that's big enough to triangulate it via parallax or some other method.
Right, that's true. And actually, Polaris is so far away that it's right at the limits of what you can calculate via parallax.
Now, we have different assumptions, so we would have Polaris be closer.
Or pretty much about the limit that you can get to for a star to parallax.
I'm not assuming nothing. Hold on, Lemon. I'm not assuming nothing. I measured one. I went 69 miles and measured 1 degree. Okay, so I'm not assuming shit. And then I went out and I measured a 45-degree angle. I'm using reality. Dude, how come you don't like me finishing my sentences? I'm using empirical fucking angles and distances we could triangulate. I'm not using some bullshit fucking distance to the center of fucking under our feet or either some parallax. I'm using empirical fucking angles and triangulated fucking distances. Nothing more, nothing less. I'm not using 7/6R.
You mentioned Polaris. How far did you get for Polaris?
3958. That's what it triangulates to, Lemon Bird, right?
Interesting.
What distance?
That is interesting.
When you actually
what they did, they took the celestial sphere and mapped it on the ground, called the Earth a sphere.
Hold up, dude. We're asking you questions, man. Come on.
Yeah, go ahead.
What you're missing here, though, is this should be the geometry of a triangle if the Earth is flat. It shouldn't be a fixed ratio because triangles don't work by fixed. The angles of triangles don't work by fixed ratios, right? It only works on a fixed ratio because these objects are so far away. The objects are so far away that over the distances that we're talking about, they would be on a flat Earth. All those objects would be directly overhead. No matter how far you go on the flat Earth, they would be directly overhead.
Bro, I can measure. It's 3,958. Here's
the problem, though. But then if you take a tangent of a triangle at 3 different locations on Earth, you get a different height for every location because it doesn't work. The triangles do not match up.
Well, we would expect that over a flat plane because things
tangent is the geometry of a triangle.
Even over a flat surface.
That's what I'm telling you. If it's a flat surface, it would be a triangle.
The thing is, for your triangle to work, all sides of the triangle need to be preserved. We know that the parts of the triangle are eaten up visually when it goes beyond the diffraction limit, and you don't have a complete triangle visually, even over a flat surface.
That's bullshit.
That's lemon bird nonsense.
So you're assuming that Earth curve is eating up the triangle when it's just the diffraction limit over a flat surface where the ceiling merges with the floor, and parts of the visual triangle you're trying to draw in your head are just cut off and, you know, invisible to the eye.
Take the tangent of a triangle. Use 3,950 or 3,959 miles for the height of that triangle, and then start applying different angles, and you'll see that you'll get completely inconsistent for every single change in angle. You'll get a different base for that triangle.
There's too many assumptions there, and the assumptions don't match the reality. You're assuming perfect triangles that map perfectly to trigonometry, and that's not how vision works.
There's no tangent on a flat Earth, dipshit. There's no tangent on a flat Earth. I'm not using a tangent.
There would have to be, because it would be a triangle, right? Because on a flat Earth, you have a straight line base of a triangle to the GP, and then you have the celestial object on the flat Earth, which is at a given height.
But the diffraction limit has already eaten up the height of the object as that side of the triangle from the GP up to the star that you're trying to measure. It's already eaten up that distance, that side of the triangle, because the ceiling is merged with the floor and cut off that quote-unquote side of the triangle, making your triangle off. No Earth curve necessary. It's
That's
just
not how it works, though,
diffraction limit over a flat surface.
That's not how it works.
You're making up shit. Like, there's no, like...
We're just using logic. You're assuming that all parts of the triangle would be preserved over a flat plane, but you're forgetting about the diffraction limit and how it is eating up sides of the triangle, eating up the angles, and making it off.
Yeah, but listen, you could triangulate.
You can't triangulate on a globe, okay?
You can
Y'all have
triangulate.
triangulation English.
God damn it, Brian. You can triangulate the same celestial body from different positions, and you'll get different elevations for it, right?
That's why we have refraction.
Oh, okay.
So that's expected, Left Lane, because you can only have a quality triangulation if you're in the neighborhood of the object. If we're in the same neighborhood of one block, we can easily triangulate the object if the three observers are within the neighborhood of the object. But if you're in the next city over or too far away from the object, it's eaten up by the diffraction limit. You can't get a visual beat on the object, and you can't triangulate it, even over a flat surface. So if the sun is moving too far away, these celestial objects are moving too far away to have a triangulation when it's outside of the neighborhood. That's all. It's not because we're on a ball. So basically, we have the diffraction limit and the object moving out of the neighborhood for a visual triangulation, eating up the parts of the triangle and making it impossible to triangulate. That's all. Over a flat surface.
So you guys are just making shit up, pretty much. You don't really... You're just kind of going out, you know...
It's basically common sense and reason, no ball necessary.
7 over 6 R.
You can't quantify it.
Let me tell you what's making shit up. 7 over 6 R, that's making shit up, dude. Assuming that I have a fucking radius that I triangulate to a star above my head, and then I convert it to the center of the fucking earth under my feet, assuming a ball, that's making shit up, bro. That's assumptions, okay?
And also, you can have 69 miles per degree over a flat surface. All you do is look at the ceiling of the hallway, which is similar to reality, where you have objects that are at the same elevation, just like in the hallway, not changing elevation, just like in the hallway, and going down toward the center of vision, just like in the hallway, at a certain rate. In the hallway, it may be that light going down toward the center of vision at 1 degree per foot. Over the flat plane, as long as Polaris stays at the same elevation, it's 1 degree per 69 miles up to a point. It's the same thing.
You can just prove that to yourself in your apartment right now, Lemon Bird, by standing under something and seeing how much it changes with every step. And you'll see that as you get further away, it takes more and more steps to make that same amount of angle change.
You just did the formula. Hold on, Lemon. He just did the flat Earth formula and got 69 fucking miles, and he acts like he never even heard it, dude. He's just brushing past it. He don't like it. We have refraction. He don't like that we have a refraction model, does he? He don't like it that our shit works out.
The thing is, we have the same thing over a flat plane, Brian. There's no difference. And also, Polaris lingers on the horizon as we get toward the equator. According to Robotham and his accounts, they were seeing it up to 23 degrees south of the equator, lingering on the horizon, it appears. So it looks like we're seeing the same thing.
Yeah, nobody can confirm that Samuel Robotham thing at 23 degrees below the equator.
Nobody can confirm that the Earth is a ball without curved lenses and NASA's lying CGI.
1 degree per 69 miles
Why
happens
do
on a.
flaggers keep mentioning NASA?
Because they're the ones that are the main ones purveying this falsehood. And also, we see it dip
No.
69 miles per degree over a flat surface just as easily as on a ball.
Yeah, I
No,
don't know about
put it
that.
on a piece of paper. You'll see it doesn't work.
Howard, I just walked
Has
it through
anyone
it. It's a
mentioned
sport
NASA?
fucker. I walked through this shit, and it works on a flat Earth using a fucking refraction formula.
You don't have to use a formula. You can just draw it on a piece of paper.
You have to make
And
crazy
you have a
assumptions.
flat
though.
surface.
For your model, you have to make a lot of
light
assumptions.
ceiling that's dipping down 1 degree per 69 miles away from it, just like 1 degree per 69 feet away from a light in the ceiling over a flat surface.
That doesn't work like that, Lemon. You're literally, come on, man.
It's the same thing. And the higher the object is off of the level of the eyes, the more slanted it will appear to dip toward the horizon, and more acute will be its dipping as it appears to dip down at a steeper incline and a steeper angle.
Yeah.
So basically, it's just linear perspective over a flat plane. They've just chosen to make it a ball for some reason.
Pretty much you're making shit up.
I don't think you know what
Well,
perspective
they already
is.
made up a bunch of stuff for the ball, so if we can believe one set of bullshit, I guess we can believe the truth.
Our bullshit works.
No, there's
Guys, you have to make assumption after assumption.
critical holes.
I don't think any
Huge
flat earther knows how perspective works.
Nope.
Basically, the part
Y'all
that's
just
above the
making
level of the
stuff up
eyes
at this
appears to
point.
ramp down. That's it. The part that's
No,
below the
that's
level
not
of the
how
eyes appears to
perspective
ramp
works.
upward.
No,
That's not how
Lemon,
So how does it work?
you can actually quantify. I mean, like if you want to call it that, you can actually. There's like actual, like you could really like I don't know.
He knows the
There's a
formula.
formula
You
for
don't.
perspective.
He knows the formula. Lemon knows the formula. You don't. So quit asking questions you don't know
Alpha
the
equals
fucking
3
answer
times
to.
the arcane of G over 2R. There's the formula.
That's
Yeah, all right, white guy.
idealized based off
All
of
right,
the
white
object
guy.
being centered in your vision, with half of it above the level of the eyes and half of it below the level of the eyes. Not everything is at that level because most of the stuff towers way above the level of the eyes, so that formula falters right there.
What?
That's what they do. They spit out a formula, dude. That's
Half
why I
of the
made a
object
formula.
above
That's
the
why I
level
made
of
a
the eyes,
formula
half
for a
below.
flat Earth, man. Because
Half
when you
above,
ask them something,
below.
they just spit out a formula, dude. They spit out a formula. When you ask them a question, they spit out a formula and act like math proves everything. So I just made a formula, fucking
Math does prove
refraction
things.
on a
Thank
flat
you.
Earth.
Look, I made a
I mean,
formula.
math does prove things.
Yeah, as long as the entire
It only
object is.
proves things if it has a concrete sort of unit that maps to reality. 1 apple, 1 plus 1 apple equals 2. But not everything is concrete like that, especially vision. We don't have one unit of vision combining with another unit of vision. Things merge, disappear, overlap each other. They're not discrete quanta. So using math like that for vision is a bit of a problem.
They don't understand all that. Lemon.
The
They don't
philosophy of
understand all that.
vision,
That's all
gentlemen.
that word salad, man. You got to break it down. You got to talk slower for them. Lemon, you got to talk a little slower
I'm
for
sorry.
these guys.
So you,
We
you
can
don't,
do this
you don't
together.
think we can?
We can do this.
You don't think we can like quantify like if once again if that's the word, but you don't think we can quantify like perspective? Like you don't think we have like an understanding of how that works?
We can only quantify the part of vision that is brought to our senses.
No.
The part that's beyond the diffraction limit, no quantification. It would have to be brought to your senses.
I think you could do it with short distances. I think once you start getting like 10 miles, 20 miles, I think you're going to start having problems. That's my opinion.
And unfortunately, since the ceiling is merging with the floor, there's just too much smushing, too much visual compression for you to make out an image, and therefore it will elude your attempt to quantify it mathematically.
It's the same thing on a flat Earth, you know? It's the same thing on a flat Earth. First 10, 20 miles, the first 5, 10, 20 degrees, you're fine. But when you start getting further than that, you're going to start having problems. You got to start, and your explanation is refraction.
Well, I think I kind of agree with what you're saying there, Brian. I think that's not a bad point. I mean, one of the things that I always say is, we always work when we're taking measurements. Maths is, we can prove maths. That's fine. But when we're taking measurements, we're always dealing with a tolerance. And that's part of the problem you deal with, which is why, it's pretty easy to hit a bullseye at sort of 100 yards, and it's much more difficult at 500, and it's a lot more difficult at 800 yards. But there's no smushing into the horizon with that. We can still cope with it. We can remove that problem of angular resolution with magnification, and we can still walk into our target or hit our target.
Well, trying to math the crap out of this is a noble endeavor, but we don't always have, perfect units that are perfectly countable and quantifiable. Sometimes we go with the math because it gives us a general ballpark or matches the activity of, what we're generally seeing. We appear to see angles that appear to, kind of taper down to a point like looking at a triangle or a pipe slice that's coming to a point. So we're going to have idealized math that is going to try to mimic that visual activity, but that doesn't mean that we're counting out perfectly, a tangent or an angle that maps perfectly to the math 100%. Sometimes we try to fudge it with refraction. Sometimes we accept it even though it's a little off, or we get in the ballpark, but it's not exactly 100% anyway. So there's different reasons why we go with
No
that.
measurement on
Hold on,
Earth
y'all.
is
Let me
ever
say something real
no
quick.
measurement on Earth is ever 100% at all.
Yeah, I agree. Let me say something real
yeah.
quick. Let
Come
me say
on.
something real quick. All right. Like I could have just what he's talking about with the tangent. I could have just said, okay, the light curves at 6 inches per mile squared or 8 inches per mile squared or whatever. Just use 1.22. Okay, I could, I'd still have a good debate whether it's the light curving or the ground curving when you're talking about long distances. But that's what he accused me of. That's the cheesy shit he accused me of. That ain't what I used. I didn't
And
use
no math is perfect, as you
I
said.
didn't
No
use
math.
that. My equation is 90 minus a, the measured angle in the triangulated distance. So 90 minus a over 90 times d times point A. And then that's your refracted amount. You subtract that from the distance you just triangulated, and that's your actual distance.
What's
And
your
it still
variable
works
for
until
D,
you get
by the way,
particular
Brian?
horizon.
What's your variable for D? That distance.
Yeah. And
Okay,
what
cool.
is point A?
Angle, I think. But
That's
I'm guessing.
a decimal variable. Okay.
Point A, like a point on a coordinate graph, or 0.8?
Point A as in apple. That's in his equation.
It'd be a constant variable that you would add. You'd add in.
Yeah, I agree with that.
Technically, it's the percentage of the ratio. It's the percentage of the ratio for it's a function of distance and angle. There's nothing made up. There's no made up variables. It's fucking just distance and fucking and angle.
Since
It's
when
a
do triangles
ratio
have
of the percentage of the ratio.
when do triangles have ratios between their angles and their sides?
Since
Have,
when do we make
linear
shit up?
ratios.
Would you rather I just made some shit up?
No, you
I could
tell me that you
I
did.
could throw in a
I'm
fucking
telling you-
number
I'm
if
telling
you
you
want.
that you did make
If
shit
it would
up.
make you happy, dude, I could throw in 1.1 and just change it around a little bit.
I'm telling you that you made shit up.
You'd never be happy, bro.
Why you try to
Trust
answer
me.
the question, man? How
You won't
how is it
let
that you
flat
have
Earth have refraction.
how
Your
is it that you
brain
have a
won't let
ratio
flat.
between the angle and the side of a triangle? A linear
Your
angle
brain
ratio.
it's distance, bro. Okay.
Yeah, right. The distance. So that's one of the sides of the triangle, and the angle. How do you have this ratio?
Listen, the refraction is a function of distance. It's a percentage of the ratio of the angle. It's that
Got
simple.
it.
I don't need to make nothing up, bro. What I'm trying to tell y'all, I don't got to make something up or assume nothing, bro. It's a fucking percentage of the ratio of the distance.
Yeah, but that's what I'm
I
saying.
mean, of the
Because
angle.
that's not
Of the
how
angle. I'm sorry,
triangles
of
work.
the angle.
Draw them a quick diagram, Brian, so you can explain it to them visually.
It's a function.
That's not
I
how
already
triangles
have,
work,
man. I
man.
can repost it. Look, they don't want us having any fucking equation, any formula.
You can go
They
ahead
want
and
to
make
make their
formulas,
shit up.
but you're
They'll
not
make
going to
up
recreate your
all these
geometry.
equations. They just make
But
shit
hold
up.
on, but hold
And
on,
just throw in a
Kosho.
fucking bullshit number. What they'll do, they'll throw in a bullshit number and call it proof. And when I use actual fucking, actual measured empirical shit, then they complain about it because we can't have. Like, we already got equations. You can't have equations. We already got equations. Y'all can't make up equations on a flat Earth.
Hey, Brian, what happens to your output as you move around to different locations on the surface?
Test it. It starts breaking down closer to the horizon because then terrestrial refraction starts kicking in. But it's good. It's good. It's as far as you can measure, as far as you could use a sextant and further. It's good.
Can you tell us the formula again exactly?
There's multiple
90
videos
minus
made
A.
about it.
90 minus A. I'll just post a video, man, and it's written down, and all the other details are written down.
If you post a video tomorrow, they're gonna come and you're gonna repeat the same things. They're gonna pretend that you didn't post it. It's the same thing over and over again.
I'm telling you,
Well,
if you understand how triangles work, this is impossible. It's just not how they work. The ratio, there's no ratio.
Well, then it's a miracle, Coach.
Angle of a triangle
Then it's a,
like that.
must be a miracle then.
No, it's not.
Yeah, it only works.
It just doesn't happen.
Yeah, you're only getting good numbers on one location on the surface. When you move your location around, it goes sideways.
You got to get another angle. Like I said, it's empirical. You start making shit up and going fucking you got to be there. You got to measure the fucking angle, the angle you measure, and get your true distance. And for Kosher to say it doesn't work, dude, he's just blurting shit out. He ain't even fucking tried it.
Listen, dude, I've studied calculus 1, 2, and 3.
No, you haven't.
I've taken trigonometry. Okay?
No, you haven't.
When you take trigonometry, it becomes blatantly clear that when you have a right angle, so the distance, so the GP to the star or whatever, so the North Pole and Polaris, and you have the angle that you're observing it from, that angle and the distance between you and that GP are not going to change at any kind of linear rate at all.
It's refraction, dude. One more time. It's fucking refraction. Okay?
But there's
it's
no
refraction.
ratio. Is what I'm saying.
There is a ratio. It's a ratio as a function of fucking distance, dude. It's a percentage of the angle. It's a percentage of the ratio of the angle as a function of fucking distance. How could you not? You say you took trigonometry
Yeah,
and you're
because
fucking
the
working on
actual
calculus right now. You
ratio
don't
is the
understand that, bro?
tangent
That's
line.
fucking simple shit, dude.
The actual ratio is the tangent of that angle.
That's like I said. If I wanted to do that, I could just say, "Hey, the light's curving fucking 8 inches per mile squared." Or something.
Sure, I
It'd be
guess.
cheesy. I'm
but
not
just
using
the
that.
actual ratio is the tangent. Yeah, the tangent of the angle.
It's not radians. It's not a tangent.
I mean, it's simple. On the globe Earth, it's just the circumference divided by 360 degrees gives you 1 degree for whatever distance.
Yeah, well,
It doesn't make
triangulate
sense
that.
why that
Show
would be on a
us
flat
in
Earth,
real
though, because
life.
we know that when we look at like
we want you to show us in real life. We want you to triangulate that in real life.
What do you mean in real life? Everyone that takes an angle, everyone in the northern hemisphere who measures their angle to Polaris will find their latitude. That's how we know that works.
Hold on, dude. You're getting a different distance. If you're using that same fucking, you're using the same equations, the same math for the sun and a star. Hold on, you got different distances, bro. What's up? Your model's fucked up. You got a different distance from a star or the sun and the moon. You got different distances.
I mean,
what's wrong
the
with
sun
your,
and
what's
the
wrong
sun
with
and a
y'all's
star are
models?
sufficiently far away that you can use those objects and multiply it 1 degree by 69 miles. and get
That's
the right
why I
answer.
said I want empirical shit. I want empirical shit. Shit we can fucking triangulate and measure here
Well,
on the ground.
empirical, Brian. It is empirical, Brian.
Bro, I'm telling him right now, dude. If we do that in his model, we're gonna come up with the same distance for Polaris, the sun, and the moon. I don't like that.
We're not worried
It's
about
not
the
empirical.
No, we're not measuring. It's not based on the distance. All that's required is that those objects are sufficiently far away that their angle would not change. Their parallax angle would not change over the small distances on a spherical Earth. The small distances that we're traveling compared to the distance that these objects are at means that there's almost no parallax change as you move that distance.
My model don't have any requirements, bro. Your model's got assumptions. Okay,
No,
mine don't.
yours is assuming the distance to the celestial body, which ours does not.
I'm not assuming shit, Howard. I'm measuring it. I went 69 miles and measured 1 degree, and we triangulated that out. It's 39.59. So there's hardly any refraction at 1 degree, right? We can agree on that, right?
But don't you have to adjust the distance though for like where you are on your flat Earth? Like that, I thought that was the whole thing. You have to like, oh, it's a different height now, you know.
Yeah.
You gotta plug it in. You gotta plug in your refraction. But it's all measured. It's all empirical. There's no made up variables, no assumptions. So your model has a problem. So what you're gonna have to do, hold on. What you're gonna have to do is prove. You said it has to be sufficiently far away. So I'm gonna need proof that you're the star and the sun and all that is that far away. That's what I'm gonna need. I'm gonna need proof for that before you could use any of that fucking math.
Present when ready.
Yeah, present would be a good thing. Are you saying you can navigate with this?
More importantly, we're going to need proof that the medium is what you claim it is in between us and the star. I think that's the most important thing here.
Start
It's
there.
just nothing. It's
Yeah,
nothing.
Start with that.
It's nothing. It
what's
doesn't do
nothing?
anything. It doesn't do anything. It just the light rays go straight. That's all it do.
Through nothing.
Yeah.
We know the baseless assertion claim that you guys make that it's an empty vacuum. However, that has yet to be shown or proven.
Or demonstrated.
Any
we
of
see
that, all
nothing.
that.
We just don't see anything that would indicate that the light is bending or wobbling or going astray. It appears to be going straight, right?
Based on what?
What we see, physical observation.
Through a medium of what? Nothing?
No, nothing. Yeah.
That's why you had to invent magic, astrophysics.
In my model, man, in my model, the sun is local, and I can prove that because you look on the horizon, and when the sun is close to the horizon, the only clouds you're going to see lit up are local clouds. Same with the moon. So we're gonna go off that as our evidence that the sun is close. We don't. I'm not going to claim exactly how much. I'm just going to say what it triangulates out to, and use a equation, as a function of fucking, just a refraction. Just it's refraction. That's all it is.
Astrophysics is magic.
Mm-hmm.
It ain't magic. Trust me. Your model's the one with the magic, bro. Now prove to me without invoking magic. Prove to me that the sun is a star is trillions of miles away. That's your magic.
Well, see, take this problem. How about you apply astrophysics to Earth?
Now, the first problem, Brian, that you have with a 3,900 mile sun above your head is that when it's on the horizon, it should be like 3 or 4 times further away, and it should change in angular size.
No, it shouldn't. It only goes away up to about it only goes like 5,900 miles away, and the closest it ever gets is 4,000. Why would we expect it to get smaller?
But if you
hold on. Okay. No. Lights don't work the same as tangible objects. If you take a light, and the further you get it away from you, the less it shrinks as you. And I can use a comparison. How about an airplane? When you see an airplane miles and miles away, okay, like 70 miles away, which is probably max, it's the same the lights are the same angular size.
Here's the difference, though. The airplane is a great example.
Hold on, that's way
This is why the airplane is a great example. I'm glad you brought it up. If I'm like sitting on a runway and an airplane does a low pass over my head.
I said the lights on the airplane, bro.
Okay, lights. Let's say it's in the dark and it's just all you see is the lights on the airplane. Okay, and the airplane, and you're on the runway, and the airplane does a low pass over your head. Let's say it's 100 feet above you, right? When it's directly above you, it's going to have a very fast angular change. It's going to be like, a degree every fraction of a second, right? It's going to be like, it's going to go right over your head. But as it gets further and further away, the rate at which that angle above the horizon changes is going to get slower and slower and slower and slower. Sun, right? Meaning the plane has to travel a further and further distance away from you to make the same amount of angular change.
Like the sun on the horizon, right, bro? Like it gets slower and slower. It lingers on that horizon. Just like we would expect.
The sun moves it.
Just described
the sun moves it. What are you talking about?
They don't like tasting their own medicine, people. Look, he just described what the sun does perfectly. Now they want to try and say the ISS, we can see it from 2,200 miles away, the light from it, not the ISS, the light from it, and they think the angular size of the light should change. That is a freaking drastic more angle change.
The sun moves at a fixed ratio. It moves
from 6,000 to 4,000 miles. You're talking drastic, bro. So for y'all to say that the sun should change angular size is that's BS, and you're not applying that to your own model.
Filter out the glare and talking about the physical size of the sun. We're not talking about the glare of the sun.
Yeah,
I mean the sun moves at 15 degrees per hour. That's irrefutable. It doesn't matter whether the sun is directly overhead or if it's close to the horizon. It still moves at 15 degrees per hour.
And you get size distance from that how?
Oh, you don't get size and distance from that.
Okay. Yep. Present when
In
ready.
your model, we can't even use a sextant past 120 degrees. That's
But that
60
wouldn't
degrees
but that means the
each
sun
way.
behaves completely differently than any other object flying overhead, right? Like an
No,
airplane.
you don't
An
triangulate
airplane
stars past
flying at a
60
fixed
degrees.
speed. Do you agree though that an airplane flying at a fixed speed will not move the same amount of degrees throughout the sky, throughout its entire path per minute or per hour, right?
I brought that up because Howard said the light should change angular size, and you gave him an example of the lights on an airplane not changing in angular size, and it's way more drastic of a change than from 4,000 to 6,000.
I didn't say
wasn't
the
using the
light.
airplane or the speed. You know,
Didn't
you
say that.
described the speed perfect on the
I didn't
horizon.
say
The
that.
airplane would slow down. That is what happens. That's what happens with the sun.
I said,
didn't
and I
say that.
reiterated the size of the sun is what I said.
Right. So I'm comparing it to other light and how it changes angular size. And then, like I said, I mean, you should just take it back because something that gets 4,000 miles is as close as it ever gets to us, and 6,000 miles is as far as it ever gets. We would not expect to see any change at all compared to other lights that we measure.
That's a third the distance. Yeah, it should change some.
So that's only So okay. So get you a light bulb. Okay, get a street light. Okay, and see if you get see how far you got to go. See how far you got to go. Don't get within. Just use 400 yards and 600 yards.
I'm looking at
do something
I've got
similar. You know how far you're gonna have to go to get an angle change? A long
Yeah,
way,
I've got them
bro.
right over. I've got them right over my head. I'm looking right at one over my head right here on the interstate, and we're going about 10 miles an hour, so I can do this. And I look at one quarter of a mile down the road, and it's more like a point source of light. I can't really make
it. A quarter mile. Wait, a quarter mile? That would mean the sun would have to be like go from 4,000 miles to like 50 million. Hold on, I'm looking at the airplane right now. Howard, let's drop this subject because I'm looking at the airplane right now, and it's coming towards me. Okay, it's way off in the distance. Okay, it's way more extreme of an angle change than 4 to 6, which would be the ratio of the sun on the flat Earth model, 4 to 6. Okay, and there's no change in angular size of the light.
But dude, you're not addressing
about
the
place,
street
right?
light. I'm looking at street lights, one right over my head and one off in the distance. They get smaller.
Yeah. Do a 4 to 6 ratio, Howard.
Obviously, they get smaller as they get further away.
Yeah, and
Howard,
don't forget that these lights that you're talking about on the airplane are beyond the resolving limit of your eye, so they're point sources of light.
Well, check this
That's
out.
the reason why all stars in the sky are point sources of light, even though they're completely different distances.
I'll need you to prove that, bro. You make claims.
Prove that?
Got no proof for nothing. It might be, bro, but so the sun's a point source light. Who gives a shit?
No, you can resolve the disk of the sun. It's not a point source.
You can see the
You're just
freaking
making
sun,
claims, bro.
No,
the sun, you can resolve the shape. You can resolve the shape and disk of the sun. That is not a point source of light.
Okay,
You can literally
that.
see
One
it
at
through
a
a
time.
solar filter.
Howard, wait. Howard with the street lights. You think your street light that's close and 1 mile up the road is a fair comparison from a 4 to 6 ratio, 4,000 to 6,000? So a 4 to 6 ratio. You think that's a fair comparison using a street light a quarter mile away compared to one right up to you? Is that fair?
The one 500 feet away is significantly smaller. I mean, it's easy to see.
So now use one 400 feet away and then 600 feet away.
Wait, guys.
You see any change?
Guys, can I jump in real fast? Okay, because whenever we talk about the sun,
Add another globalist to the.
Oh, yeah, okay, yeah. So anyway, whenever we talk about the sun,
flat earther.
Okay, anyway, so whenever we talk about the sun, right? This always happens. It's like, oh, it's a light source. Okay, why don't let's go to the moon? All right, the moon still doesn't do this. All right, you have the moon is obviously not some point source or whatever, and it doesn't follow perspective. Okay, so we could still do
Yeah, well, go ahead and make your claims for the moon. Y'all got claims, right? You got claims for the moon. Go ahead and make them, man. Let's see if we can prove any of them. What are your claims for the moon?
It's the same thing. The same thing with the sun. Whatever we're arguing right now about how it doesn't really follow perspective. You say, well, it's a point source, so we wouldn't expect it to see, get smaller. But with the moon, we don't see that get smaller. So it's the same argument we have with the sun, just now with the moon, where it's obviously not a point source.
Well, until one of y'all measure something with a 4 to 6 ratio, make sure it's at least way off in the distance, okay? Because the sun or the moon never gets about 4,000 miles, okay, in my model, okay? So use something real far away and then something just a little bit further, because
You could just
it's
measure.
use a 4 to 6 ratio, dude. You're not
You
going to
could
get
just
angular
measure.
change in light at that distance, bro. I mean, y'all should know that. We should be on the next subject. This is
You not
stupid.
wait for the
dude.
moon? We don't expect the moon to get smaller.
If it never gets within 4,000 miles of us, or 3,900, whatever you want to call it, and only ever goes 6,000 miles away from us, it's all right there in the same vicinity. So you use a 4 to 6 ratio and prove to me that light changes in angular size from a 4 to 6 ratio, starting freaking 100 times the distance to begin with.
You flat earthers are really proving to us that you guys don't understand perspective. I mean, if
You're proving that you're just gonna fucking claim any fucking thing you want, bro. Because I done used the ISS. ISS, you're supposed to be able to see it for 2,000 miles, but it doesn't hardly change angular size at all. So why should the fucking
You keep equivocating point sources with objects. I don't know why you keep doing that.
This is really good because it shows how the sun.
Reasons, right? You got reasons.
Yeah, I like it because it shows how the sun and the moon are about the same size. They must be the same distance away. By globe logic too.
The sun and the moon. The sun and the moon are resolvable objects with a resolvable shape, a measurable shape. You can measure the disk and the width of that disk. That is not a point source.
Present when let me see your paper. You got paper? You got an experiment?
It's like talking to donkeys, Crit. It's like talking to
No, okay, hold on. So
you want to learn. You don't even want to learn our model at all. You don't want to learn. You just want to say, no, that could never fucking happen. No.
Okay, so
and then say it can only happen on my model. And offer no proof or demonstration of y'all's bullshit at all.
Okay, so from my understanding of how perspective works, or at least from my understanding anyway, right? If you double the distance, right, you half your height, okay, visually, okay, like in the distance, right? So if for the sun to be half as high as it is in the sky, it would have to double its distance, all right, and you would have to keep doing that, and obviously you do that until infinity, and that's when it finally hits the horizon, all right. The fact that you're disagreeing that the moon, like the fact that you don't think, I don't know.
Let's do that with your ISS.
Your understanding of perspective is just weird, man.
Hold on, let's do what you just said. You're going to stick to your fucking claim for once. Let's do that with
my claim. Yeah, let's go.
Hold on, let's do that with an airplane that just passed over my head. Okay,
Yeah,
it was about 50 miles away. It was about 50 miles away, and it measured to about a 16th of an inch. I'll call it 5 arc seconds, whatever. Okay, at 50 miles away. Okay, that's just an example. That's just an example. Now, so when it travels another 200, let's say, eighth of a mile. No, 50 miles. What are you talking about? I didn't say the sun goes from 4,000 miles to 8,000 miles. No, it goes from 4,000 to 6,000. Okay, so look, so when the airplane gets over my head, it's going to be 7 miles away, or probably more like 5 miles. Okay, and it ain't changed angular size like you're talking about, bro. You're not going to call the airplane like a point source. You're going to come up with some bullshit excuse to stick up for your model, bro. That's what y'all do.
Man. Prove that when it doesn't go when it goes twice as far away.
I'm trying to use something common sense, bro. That anybody could go outside and just look at the airplane and see that a 4 to 6 ratio, ain't gonna do nothing, bro.
4 to 6 ratio. That's not good. That's not correct.
There's a thing
4,000 to 6,000. That's my model. 4,000 to 6,000. 4 to 6. Ratios? Learn them.
They would like that ratio because I would give them some flex to change their numbers later on.
That's
which is what they'll do. They'll say later on in the future, be like, "Oh, hey, the moon's actually further away because this 4 to 6 ratio still fits it."
How far the moon is, man. Right, it's not going to change to 4,000 miles overnight.
Let's see if I can find it. Unfortunately, I only deal with 3D programs, so in the 3D program, if you double your distance, you're having your height based off of the horizon or whatever. I could show you that in a 3D program, not in real life because I don't really have a setup like that with a camera. But yeah, that's my understanding of how perspective works. And so, if for the moon to be touching the horizon, like going down and touching the horizon, it has to get smaller. It's just how perspective works. I mean, the fact that it's going down as far as it is, it should be getting smaller and smaller and smaller, and the moon just does not do that. All right, like
how do you know what happens to light if it only ever gets 4,000 miles close? You think it might change? So an airplane that's 4 miles away, the light from the airplane, not the airplane, because it probably ain't gonna change either, but the light from an airplane 4 miles away compared to the light from an airplane 6 miles away, you think that's going to be measurable?
Well, if it's like the point source thing the other people were talking about, then I mean that's a different story. But with the actual airplane itself, it always gets smaller though, and we can
see the light. You're talking about the light.
Well, yeah, well, I was talking about the moon though. I mean, the moon. I mean,
the light.
Okay, it's fine with the light, but with the moon though, we don't see.
Which is the light.
Yeah, we're talking about point. If we're talking about point sources, you're talking about point sources. If you're talking about the sun and the moon, those aren't point sources.
Yeah, especially the moon.
Those are going to decrease in size.
The moon can't even be a point source because for it to be a point source, I mean, I imagine it would have no there's no resolution. I mean, the fact that the moon has details on it, that's not a point. I mean, it has detail on it.
My point is, my point would be you can't show me the difference. You can't show me the difference in reality of a light 4,000 miles away and 6,000 miles away because there's no way to prove that we could even see a light that far away. If you want to get right down to empirical measurements, we're just speculating. Everything we say, we're speculating, man. We're modeling. For lack of a better word, we're modeling. Okay, what would happen on our model? Okay. So y'all are telling me what happens on your model. I'm telling you what happens on my model.
Yeah, you can.
We can't prove
you can prove that you can see 6,000 miles away.
The sooner y'all understand that you can't prove all y'all's claims,
dude, by your own logic.
You got a good model, dude. I'll give you that.
You're not even fucking thinking about the things that you yourself said. You yourself had said that you'd measured, or you have a prediction that the equator to the North Pole is 6,000 miles. Okay,
it's a model, dude.
Yeah, that's great, dude. That's great.
I can do that, Benjamin. I can get that close. Hey, listen.
Yeah,
Coach, you're strawmanning me, dude.
Stop being a pussy and listen to the implications of
what
you
strawmanning. You're talking distances on Earth, though.
Yeah,
don't compare distance on Earth
Stop for a second. Stop for a second. You yourself said that distance was at least 6,000 miles. And if you're on the North Pole and you're looking at the fucking sun on the equinox when it's directly south of you, it's going to be at least 6,000 miles away from you because that distance is at least 6,000 miles away, and it's known to be directly over the equator. So you can definitely see something that's 6,000 miles away by your own accord.
Yeah, but it's just a model, though, man. But you're right, though. I can measure distances on Earth, to a certain degree, and but I'm talking about when we're talking about the heaven, the sun, all that shit. I mean, let's be honest. Can any of y'all be honest and say, yeah, it's model? You can say, yeah, we got evidence to back, but it's model. It's a model. We can't prove it 100%. There's no way to. Would y'all at least concede that?
It's not a concession. Nobody claims that.
Okay, so when we say a star is 5 trillion whatever miles away, that's a story. It's a model. You might have some math to back it. A good model. You'll have a good model. Okay. But it's a model. It's not fucking,
It's not good even because it uses magic. It uses astrophysics. That doesn't make even a claim about Earth to begin with.
Astrophysics is not magic.
Can you use astrophysics to describe Earth?
Yeah. There's things you have to use physics on Earth to describe things that happen in astrophysics.
Astrophysics, cosmology.
Boom, right there. Astrophysics is a scientist who studies the physics beyond the Earth. You're done right there.
The physics beyond Earth is the same physics.
Beyond Earth is not also beyond Earth at the same time. That would be a contradiction.
It's not different physics, dude. That's how they claim to know what's happening out there, is by understanding the physics on Earth.
Yeah, you would fail any level of testing in that parameters. And that's why you can't follow.
That's rich, Grit. You're trying to prove the Earth with astrophysics, right?
No, you are. That's why it's magic. You can't
no, we're not.
Your same physics to the subject.
That's a huge straw man.
See, you can just ask. This all of a sudden your Google doesn't work.
That's from you. Yeah, that was you.
No, that's not me. I gave the source right there. Ask the expert. See, this is what you guys deny experts. Stop denying your own experts and to make it seem like you've got some secret knowledge that no one else can Google. I could Google the same thing you did, and boy, were you guys wrong. You couldn't even regurgitate what the experts say.
Googling stuff. What are you talking about?
Yeah.
Jesus Christ, dude.
I have a question for the flat earthers. How do you explain gravity if the Earth is flat?
What
When
kind
you
of
say
gravity?
gravity, you're talking about space-time bending?
No, we're just talking about Newtonian gravity.
Well, that's not a thing
So
anymore.
you're talking about
Literally no
things,
He's speaking for
things
someone
falling
else there,
down?
Howard.
Do
Just
we
let the
not
Talking about
guy.
know?
things falling down?
Let the watch. This guy will rage out. Just let him go. Don't back him up.
Are you talking about things falling down?
Sure, mass attracting mass, basically.
Yeah, you can have that on a flat Earth. Absolutely.
How?
Headshot. Done.
What do you mean, how?
How do you have mass attracting mass that would form it into a sphere? And gravity pulls.
Unless the ground was flat.
Well, gravity pulls toward the center of mass, so it would pull it into a sphere.
Okay, you realize I can take a object, you know, put some magnets or something under it and make it so that all the mass is, all the mass is attracted to the floor, the flat floor.
What?
You can have
Well,
mass
okay,
attracting mass on a flat Earth, dude. This is not even a
Okay,
far fetched. It doesn't always have to
See,
form
this is
a
what we're
sphere.
talking about. He can't even Google it and repeat what Google said.
Okay, so I'll just try to explain to
I don't use Google.
Kickin' Chicken. So okay, so basically there was a conversation a while ago how mass attract mass could potentially work on a flat Earth. I don't know how legit it would be, but basically for you to have like the flat surface, whatever, you can kind of have it where there's more mass, sort of like if you distribute the mass like in a weird way. I mean, it might work, but I don't know. It's but you have to assume that they even believe in mass attracts mass, though. You know what I'm saying?
Yeah,
Like,
Yeah, even if we did, it could
infinite-
happen on a flat Earth
infinite
if you have the
plane
mass
for it to work.
distributed in a certain way.
yeah, like
it
an
could work
infinite,
on a
like
flat Earth, so.
yeah, like the infinite plane thing. But you have to assume they even believe in that,
It's
though.
interesting,
So
man.
I think it's a
That's fine. I'm willing to give it, even though, I mean, there's this Newtonian gravity right here. It doesn't matter. I'll
Doesn't
give you
matter,
the
they-
mass attracting mass. It happens on a flat Earth, so now what?
Headshot.
Yeah, so then you're claiming the Earth's infinite.
What
It
next,
doesn't have to be
Logan?
infinite. It
It
doesn't
does
have to
have
be
to be
infinite.
infinite.
No, it doesn't.
So what
It's
He
ridiculous.
says it has to be infinite, and how do we not know it is infinite?
For it to work, if it wasn't infinite, then there would be different. The gravitation.
You want plumb lines wouldn't be parallel?
directly downward.
All gravity is a
So
fucking
if
rate
it
of
wasn't
fall.
infinite, hold on, guys, hold on a second. So you're saying if it wasn't infinite, plumb lines wouldn't be parallel?
I'm saying if it wasn't infinite, I mean, if the Earth wasn't infinite, then as you move across the Earth, down would change completely.
Yeah, so plumb lines wouldn't be parallel.
Well, no, it's more than that. The whole entire Earth would not have the same down. So it's like down.
Okay,
for
unless you have the mass ending really far out, like way away from us, and it's really dense and thick underneath us, then you might not even notice.
Well, that's what I'm saying. It has to be infinite. Right?
Not infinite. What if it just went a million
Big
miles?
G and little G on me, dude.
Brian, hold on a second,
Gravity-
bro. Brian, 1 second, bro. If it goes out a million miles,
Is it 1,000,000 miles?
miles from the North Pole, yep.
Let's see.
It's like a
What are you doing, math? He said, "Let's see." Would you pull out a calculator?
See, why do you have to
that's
save
not
this
so
guy?
quick, man. That's pretty
All you do is try asking a question. The self-identified King Kocho of the man has to then say, "Hold on, let me talk to Jeremy again." The same guy I've talked to for years and can't follow a single thing. Why not just let the new guy? He's got some questions, dude.
What's
Maybe
up,
you should
Pickle?
listen
What
to
was his name?
Kocho.
Kicking chicken.
Kicking chicken. What's up, bro? What's up? What do you got? What else you got? We got mass attracting mass on the flat Earth. Now what?
When the mass when you have like as you move toward the edges, wouldn't it like pull you?
Where's the edge?
I'm talking about like at the ends of the Earth, like near the ice
Yeah,
wall. Let's
where
just say.
is that happening at? Is it 1 million miles? Is it 10 million miles?
Well, here I put an image to simplify it. in the
So is
thing.
gravity an effect or a cause? You know, are you using it as the cause and the effect? Because
It's
all
an
we're
observed
witnessing is a rate
phenomenon.
of phall. So we
Gravity's an
get an
observed
average
phenomenon.
Don't
empirically.
derail.
Hold on, Howard. Empirically, all we get is an average rate of fall for solids in a normal atmosphere or a vacuum, whatever. We get an average rate of fall for solids. Okay, everything don't obey that. So it's just an average. So that's an effect. It's an effect of entropy,
It's
basically.
not an
Man.
average, dude. I don't think you know what that word means. If it were an average, that
Well-
would mean that there's things that fall faster than that. There's not.
It's been demonstrated, Kosho.
No,
Look
it
it up,
has
bud.
not.
Yeah, it's been demonstrated to be an average. I
So in your
on this.
world, hold on, in his world, the golf ball and the ping pong ball should have the same wind resistance, but the ping pong ball should have a little bit less resistance because it's a little bit smaller, just a tiny bit smaller. So the ping pong ball should fall a little faster in his world. It does not. The golf ball falls and accelerates, whatever you want to call it, considerably faster. You can tell the difference within about just holding it up about 7 or 8 feet, much less 200 or 300 feet.
You're forgetting about
Your shit is it's all in your head. It's all on paper. It's not reality, bro.
See,
You're
I
forgetting about
on Brandon's. Brandon saw, this is Kosho saw this. Brandon saw this. We all looked it up. 9.8 is an average.
Okay,
This is explained multiple
So is it your
times.
claim that
by
things fall
multiple
faster
sources.
than 9.81 meters per second squared, and then that's an average?
What,
Considering
what
that
they
a
mean by
ping pong
average,
ball is not-
Kosho, is on
ping
different
ball is not
locations
gonna
on
fall
Earth.
nearly as fast. And so for it to be an average, something would have to fall much faster. What you're talking about is the rate of fall in a vacuum.
In my world, nothing falls at all unless you give it energy to get it off the ground to begin with. Some type of energy or some type of displacement, whatever, to get it off the ground. Some type of heat or some type of force. You got to, or else it's just going to sit right where it is. If it's an apple, it's got to grow off the ground, all kinds of processes, and anything. It's got to use energy to get off the ground to begin with, or it's just going to sit there. When I walk outside, I'm outside right now, nothing's falling.
Everything's in equilibrium.
Kosho, doesn't that fall faster in a vacuum and slower in water, and even slower in oil?
Everything falls at the same rate in a vacuum. There's
Yeah,
no.
and we have to go to the vacuum.
Okay, so a helium balloon, hold on. A helium balloon and a lead ball fall at the same rate. Look, I got videos of helium balloon. When it gets down to a vacuum, it just barely trickles down. Usually they pop, but you got a couple of them to just trickle down. I showed it in a video. So in your model, in a vacuum, the lead ball has to fall at the same rate as that helium balloon that's trickling down. Bro, it's not reality. It's not math. It is not, I repeat, it is not reality.
Right, and you pull in a vacuum in that chamber, it doesn't instantaneously go to a vacuum. It slowly pulls down.
So the last few molecules are enough for it to go from trickling down to racing down then, right?
Here, there's a video this guy shows he used instead of 9.8, just 10.0, and got the same prediction for a basketball. He said in these aspects, you can use an average, a range for this gravitational constant, small g. But if you want to do things like a satellite or like a look for oil, then you're gonna have to use regional Pacific, like the exact number for that area.
Yeah,
that's true.
The rate is always within
an average.
9.
Welcome to flat Earth.
It's always within 9.81 meters per second squared. What he was talking about was
That's what I'm saying. This is great. You guys learned it. It's an average.
He was talking about terminal velocity and things falling in a medium.
Yeah, that's an average.
Yeah, for that to be an average, and you comparing the things that are falling in a medium, you have to have things falling much faster. Okay, so that rate is the rate that things fall in a vacuum. You can say it's the average of the rate of fall in a vacuum, but it's not the average of the rate of fall for things.
Once again, he got down to the best vacuum he could get, and only a couple of the helium balloons, most of them popped, and some of them didn't sink at all. Okay, he had to use real tight balloons, but they barely trickle down. Okay, there's not enough air in your model. There's not enough molecules to all of a sudden have it start racing down to keep up with a lead ball. It's reality, bro. Reality doesn't always match models, man. Sorry.
I have a question. How fast does it fall in the liquid mercury?
What difference does that make?
Excellent question.
Because
he's
it bunks to 9.8 meters per second. That's why.
No, buoyant.
Yes,
Christ, man.
Buoyant. Yeah, buoyancy is the thing.
So right there at 6 minutes after the hour, Kickin' Chicken posted his question, and you guys want to talk about vacuums. At no point did he invoke any vacuum in his question.
No, Brian
I don't
did.
think you should dictate how I ask my questions.
Why not?
Keep
Yeah,
going,
you guys
I'm
should let
actually
him do
interested in
it.
this
Just
topic.
let him ask his question.
I did. Go on. I'm actually interested in what y'all are talking about.
This is
Go
good
ahead.
though. It's a good aggressive conversation, argument, whatever. No ad homs. Let's keep it rolling.
Hey, Godric, what you asked about the mercury, you understand that acceleration and velocity are two different things. So the acceleration being exerted onto an object is going to be constant, no matter how slow it's going, because it's in a medium. Okay, it's just being counteracted by the that medium, the density of that medium, but that acceleration is still occurring.
So the acceleration is occurring even though it's going up.
So what?
Like so the acceleration is occurring even though it's lying flat on a bed of mercury.
Yeah,
or
the acceleration is being applied to it, even though it's not. So it's like if you were to do the math, you'd say, okay, it's got 9.81 meters per second squared, and then you would do the drag equation for how the medium is affecting the object, and so you would subtract one from the other.
The acceleration
And
downwards
then you end
occurring.
up with the actual velocity.
So let me get it straight. The downward acceleration is occurring, though the helium balloon's going up.
Yeah.
Is that right?
Isn't that what I've been telling you, Godric?
How do
Still
we prove
work?
there is
What's up,
a
Kid
medium?
Chicken? How are you, man?
Doing good.
Yep, and still works on a flat Earth. Welcome to flat Earth. For your model to be right, it would not work that way. Done. Self-debunking, the best type of debunk.
You can't just say words and say done, Kriya. You have to demonstrate.
Yeah, show me that not working on flat Earth.
The flat Earth. There's no model for the flat Earth, man. There's nothing to debunk.
Yeah, show me. You show me.
Yeah, Brian presented the whole thing for that today.
Yeah, and Brian's equator is 38,000 miles around, right? There's no evidence that the equator is 38,000 miles in circumference.
Did you do that, Brian? Did you say that?
If he multiplied that times pi, no, wait, 6170 times 3.14. No, it ain't that big, Coach. Why are you adding
times
shit,
two?
dude?
Times
either.
two times
Be
pi.
bigger than that.
Yeah, times two. Yeah. Times two, but still, you proved to me that it's not.
Dude, I've traveled around the world east to west, man. It's not 40,000 miles.
And I showed the boat races to show you the lopsided times for the world records in the northern hemisphere and the southern hemisphere. And the world record 24-hour leg for the Vandy Globe, this is the world record now, averaged 22 miles an hour. One funny thing is the guy was right by Cape Town and in second fucking place. So he gets the world record. He's in second place. The other guy's way out to sea. What's that tell you? That tells you that if you look at his boat, he's doing way fucking faster than 22 miles an hour. He's fucking flying. It's the dude on the Boss. Okay. Now, B, that tells you that the distances near the continents are right according to your model, but out in the middle of the ocean, they're covering more distance, man.
Wait.
That's,
You said the boat is hauling ass, right?
dude, it's flying, bro.
Yeah, but do
Dude,
you think it's
you
that?
gotta
Do you think
understand, I
it
got the
did
one dude
something?
saying that he's doing 46 miles an hour. He with 50 knot.
Do you think it did that the entire race?
Dude, he was saying that he hopes that the wind slows down by tomorrow because it was getting on his nerves. He was going so fucking fast. So they were hoping the conditions would calm down by tomorrow, is what he claimed. It's in the video. Okay, but the point is that the average 24-hour speed was 22 miles an hour. If you put that in the North Atlantic race, they would barely made it over halfway for an average race. For just an average race, the world record speed from down south would have only made it 1,900 miles in a 4,500 mile race. Would have, or not? No, in a 30. Hold on, I don't want to get it wrong. In a 3,600 mile race, the boat from the south, the world record, I might keep saying over and over, would have barely made it over halfway to an average race in the north. So that tells me there's something fucked up with the distances right there, because speed is just over time, right?
Tells me the circumference of the lower latitudes are shorter than the ones at the equator, around the equator.
So just saying words.
No, it's just numbers.
Anyway, looking at the times and all that of them going around the equator, or going around like 50 degrees and all that, it just matched up to way bigger than the 25,000 miles that your globe has. It's in my opinion, it's bigger anyway. But that's the best I could do, is take the times of the boats and shit. I'm not going to use airplanes and all that shit because they're going to write down, I don't know. If they gave me access to the data, it would be more reliable. But I had access to the data for the races, and they weren't trying to plot nothing. It's just they weren't trying to prove nothing. It's just the world record times and how long the race is, and it's even on a globe model. So that's where the differences come in. But I've modeled it with it a little smaller. I modeled it also a little bit bigger. That's just the one that seems to fit reality to me.
How many days?
It's the only logical conclusion. I like to see like all the globalists in here. You just had a new class of astronauts. They thank God and they all prayed together. Completely live stream. They talked about like another possible $5 billion for NASA. What are you going to do today, tomorrow, and the days to come to see if you can be the next 12 to be selected in 2 years? Because I predict you care less about space than I do. And I know it's hokey and it's fake.
Well, what does it say about you?
That I care less
why
about
do you care
space?
about something that you claim is fake?
Because it's entertaining. I like to watch Jedis do lightsaber battles and and things like that. That's fun. Well, yeah, like the Force.
Wow.
So you've got 2 years to get your name. Oh, also too that they're picking 2 non-Americans. So only 10 have to be American now. So the thing about, I'm not American, I can't be an astronaut. You can now, but you have to be a non-Christian too, though, because they're taking 2 non-Western, non-Christian candidates every 2 years now. 1 man, 1 woman. So there's a lot of opportunities that people didn't have just a few years ago, 2 years ago. And would be even better is if you act now in your own model and you believe their timeline, you could be on the moon. You could be constructing the next fake station. But you have to be able to act on your belief systems. And that might be a hard pill to swallow because you're going to find out very quickly that there is no space. You'll apply for NASA and they'll say, no, thank you, no space. Sold out. But hey, prove me wrong.
What are you talking about, dude?
Prove me wrong. I predict in 2 years it'll be exactly the same set of conditions as today. You could probably clip this conversation in 2 years from now when they announce the next 12 astronauts, and you could have exactly the same conversation because nothing changes under the sun.
I think Kosho's young enough to go. I think Kosho should apply.
I might have to go fix the James Webb in a couple of weeks.
There you go. Be sure and take a P900 with you.
That's
They
what I
went
was trying to
through.
explain yesterday. Was NASA is the one who came up with the CMOS sensors that are in the P900s.
Wow.
They went through like all the people too, and they had all these different backgrounds. Like one worked on oil rigs, one was a fighter pilot. You know, one was like the first woman fighter pilot in so many years. So you got chances here. You can be, hey, I'm a Discord mod. Is there any representation of Discord mods as Acronauts? And you'd be like, that could be a boon. Put it on your resume. You could write down how many social media victories you have against flat earthers. And if NASA won't take you, maybe Space Force will. You could be like like for Twitter wars against some sort of alien consciousness. Maybe their warfare is all about social media roasts. Like, damn, this guy's good.
Is there anybody who can hear you when you talk? Like your neighbor or someone at your house? Because I feel like I don't know how they cannot think that you were just a crazy, crazy dude. I mean, I say some crazy shit too, though. So
Which part don't you get? It kind of reminds me when you said the other day, I go, hey, I'm more sure about flat Earth than anything I've heard or I've ever said before. And you're like, well, what about being a man or a male? I go, did I say that? That's what you said.
You said I'm more certain about the flat Earth than anything else in my entire life.
I've ever said before.
Yeah, anything else? Yeah, being a man. I mean,
that's what you do.
You have higher.
You identify as a king and you identify as a man through multiple different sock accounts that change daily. That's not me. That's your claim. That's something you do.
Sock accounts am I
not me.
About?
Yeah, this King Kosho the man. That would be a self-identify. That has nothing to do with me.
Talking about, dude?
I would say if you've got to tell people you're like a smart guy doesn't have to tell people they're smart. You're a wise person doesn't have to tell people they're wise.
Anything. I don't know.
If you gotta go around telling people you're the king and you're the man.
When have I done that?
Hey, Crit, man, why are we going down this path?
Oh, I thought it was something about being crazy. Like if there's people in the house, they would identify me as crazy.
You're saying a bunch of crazy stuff, dude.
Yeah, is that the path that, or was that my path or was that your path?
Well, you went on about how us applying for NASA and all this other kind of stuff.
Yeah, so was that my path or your path?
That was something you went on about. I was just
you brought up
a little bit.
So that's the key. When you try to follow your own logic, you always end up with egg on your face.
What are you talking about?
Man, you're gonna have to like get the spatula out, Crit.
You can.
Anyway, I mean, do you have anything substantive to talk about, or is it just fantasizing about NASA or whatever?
Yeah, some more NASA stuff? Is that what you're looking for? Infotainment?
No, yeah, that sextivus that I made, the celestial navigation, it works perfectly on the globe, and it doesn't work on any of the projections. I tried it on the flat projections, making the circles of equal altitude. It doesn't work on any other kind of map.
So P900. So the P900 was invented by NASA.
The CMOS sensor, yeah.
And you're the one who invoked NASA, and then end up with egg on your face when someone else talks about NASA.
I didn't invoke NASA, dude. That was you. I wonder where you're going with it, but
all right.
But regardless, yeah. Anyways, the celestial navigation doesn't work on a flat Earth.
How do sock accounts work on a globe?
I don't know. I don't even know.
Okay, what actually is this conversation?
What that means.
You have no idea what that means? This is your
No idea what that means.
Like, how many sock accounts do you have?
I think
I
Gosho's
raised my
trying to re-steer the conversation, but Grit's kind of got his claws stuck into this one. I don't know.
Oh, okay.
We start. This is my understanding, right? You keep telling me what doesn't work on the flat Earth. How about what works on the globe?
I mean, everything.
Like
Everything
sock
happens.
accounts? Everything? How about sock accounts? How do sock accounts work on a globe?
Rain works. The weather works. I mean, everything works on a globe. Can't think of anything that doesn't work on a globe. That's real. We had a conversation with Lemon earlier about sidereal days and solar days. I was hoping he was still here. I was going to show him something.
How do socks work on the globe?
You put them on one foot at a time, I guess.
And that's not see. You invoked mental illness problems. You invoked mental health issues. Now explain to me this thing of sock, block, squawk over and over again for years, all based on a topic you think you've debunked. That's what I'm looking for. So if you think you've
Did his connection die?
Is Lemon still in here?
Yeah, somebody pulled the trigger out.
Lemon, if you are still in here,
Give us a sign.
but regardless, I posted this and I'll just show it to Lemon some other time. But we were having this conversation earlier about mean solar day and sidereal day, and how there's 366 solar days and 365 solar days, but a solar year is 366 sidereal days. Anyways, regardless, I posted this fucking thing that I made. It took me way too long to make this, but
Oh shit.
yeah, you can see that there's, if you imagine each circle as it moves over, it's rotating once, we'll say. And so that's one rotation, two rotation. It goes around 20 times. But you can see that the actual that's only in reference to the the sun or the center point. So there's a line pointing at that center point. There's another line that's pointed in the same direction each time, and you can see that makes an extra lap basically. So it does an extra rotation per rotations around that thing. So there's 20 solar days, and there'll be 21 sidereal days in this example. But Whitson and Lemon were going on about this for a long time earlier.
What is that again, though? Like, what is a solar day thing? Like, I mean, I know you kind of just explained it, but like, what is it? Like, is that like the Earth around the sun? Or...
It's exactly like this. Like every day. So if you look at the number 1 and you look at number 2, the difference between the rotations in number 1 and number 2, there's an extra bit of rotation that it has to do in order for the sun to be back in the same position.
Oh, okay. No, never mind.
The solar day is a little bit longer than the actual length of the time it takes for it to rotate one time.
Okay, I get it now. I got the full context now. Okay, I see what they're talking about. Or are you talking about? Yeah.
Which it was saying that it rotates faster or something like that, but it doesn't rotate any faster. Just the day is just longer to accommodate it.
Yeah.
Room. Somebody bring something up. Anybody?
I mean, I'd rather not because I don't want it to be a circle jerk. Because I'm probably gonna bring up something about, oh, they're wrong about this, and then no one's gonna talk. I don't think. But I don't know. That perspective stuff is weird on their side. I don't know. Wait, do we have any flat earthers to actually debate? Brian's technically still here. I don't know.
So the globalists learned today gravity is an average. Brian's formula works fine with a 4-to-6 ratio. Mass attracts mass works just fine in flat Earth. So are done with these questions, or they be back again tomorrow?
No, it could work on the flat Earth. Mass attracts mass. I've always wondered why the denial. I mean, I understand that that matter would seek its least its state energy state and form into a sphere and blah blah blah. However, I mean, when you drop stuff, it falls, and it's hard to deny that. And I think it would be there would probably be a more effective or legitimate argument to come at it from another angle besides denying it.
What stuff do you see falling?
Anything you drop, you're not falling. I mean, you're not flying off the surface. The same thing that's keeping you from flying off is keeping everything else from flying off.
I see gases fly off.
Yeah. Yeah, some of it bleeds off into the up there.
Or goes up, right? Not everything. There's no directionality to gases. It moves freely in all directions. I would say the only time you see something drop is if you pick it up and put energy into it, and then take that energy away. And that's how Einstein described gravity is not a force. The force is what's moving it upwards. This is Sabine Holzfäller. She showed an example of the elevator or the building. The building is what's holding someone up. If you remove the building, you remove the force holding them up, and then they fall.
Yeah, but the other force overtakes you or any object.
That's what I'm talking about. Just look up gravity, right? What is it? Is it the force or not the force?
I don't know. It's such a semantic game that gets played with it. And of course, Sleeping Warrior and Nathan really muddied the water with their denial and saying that Einstein obliterated, obliterated Newton, which that, you know.
There's consequences.
Yeah,
If you call it a force, you can't call it a force because there's consequences to that. So they can't call it a force. It's more contradictive shit. The devil's always in the detail. When you really look into it, you realize they can't have it being a force because there's consequences to that destroy their model. So they can't call it a force. They want to use it as a force, but they can't technically call it a force.
Yeah. I wouldn't say they can't call it a force. It depends on you know.
They can't, bro. They can't. It's a model killer. If it's technically a force, then their model's dead, bro.
Wait, why though? What is your reasoning for that?
Oh my God, you don't say it 100 times. I'll be right back, and I'll go over it again. If anybody want to back me up, but why do you think they just? Well, why don't I mean just something to think about for 2 minutes? Take it back. Why don't they just call it a force? What would be the problem with that? Why don't they? If they're going to use it as a force, why not just call it a force?
Probably because of Einstein's how he described what it is, the warping of space time and shit. That's probably why. I don't know. Or maybe it's also because it's like with centripetal force and centrifugal, like it's a quote unquote force, but it's not like a force, like it's not like magnetism where it's like, I don't know, it's weird. It's a pseudo force. I mean, it still has force properties or force, like it's I don't know.
It's
The
because
numbers,
it doesn't act like other forces.
Yeah, but I don't think it's a killer or whatever, like a model killer, or whatever the hell he was saying. I'm not too knowledgeable about gravity and all that, so I don't want to talk about it too much because I'll be talking out my ass. So.
Well, I'm talking about it on a fundamental level. I've never even, before I came into this community, never gave it any thought. I mean, it is, it's there. This is what it is. And this is how we studied it. I took physics in college and and all went, and there it was. But to really think about it and put myself like in a flat earther shoes, and they say it's not a force or it's magic or, two things that, that you just put them close to one another and they attract one another, and it can be, sand or lead or all matter, anything with mass has a property of attraction that things just tend to go towards one another. And yeah, it is pretty wild if you think about it. But still, in the same token, it's hard to deny. Pick something up and drop it, it falls or it goes down.
Mm-hmm.
But you have to note that you picked it up.
Yeah, but see that's kind of, and not being derogatory, that's really kind of silly just to say. I mean, first time I heard that, I was like, what? I mean, why did the rock?
What? Because it's returning to its equilibrium. It's right back where it was before you picked it up. In other words, you're taking it out of the medium, so it's going to return to the medium.
So if I go undercut dirt,
No, robot.
Can you start again from the beginning? You were roboting.
Oh, okay. I just saying if you go like a cliff and you undermine the face of that cliff such that the rocks on top fall, there's a rock slide. So you didn't put any energy into those rocks that fell. So I mean, why did they fall?
Right. So don't Globers believe that the Earth created the mountain and shot the mountain up? Isn't that what you believe? So the mountain was pushed up at some point, and you're terminating. It's the same thing with the tree. The tree grows and it creates fruit, but all that nutrients were coming through the earth, pushing up. Then the fruit falls down, eventually hitting it on the head.
Okay.
So you should consider that you're taking the object out of the medium, and then when you let it go, it's going to return. It's going to try to return to the medium. You know, you can move it somewhere else, of course, but you know, a pen off, pick it up off the table and drop it, it'll return to the table or to the floor. So you're putting energy in picking up, and then it's going to go right back down.
So it has no lateral bias; it just has a downward bias.
Why would it have a lateral bias?
So you could.
This is like the insanity of the globe.
Why does it have a downward bias?
No, you're right. You're right. You have to. This is why you say lateral, because in second grade we were taught, hey, lucky, good thing for gravity, we would float off into space, right? And we believe that, right?
Yeah.
So that's why you think stuff's gonna go sideways.
But you know, the degree of utility that's inherent with what I call the model, and I mean, it's pretty darn correct. You know,
You say it's
that
correct,
we
but
can
can
use
you
it.
show me something going sideways, please, without NASA foolery?
I
No,
showed you earlier.
No, it shouldn't.
Hey, I explained
Yeah,
earlier
go
that
ahead,
you
Chris.
could use a range. You could use 9 to 11 as your as your small g. And if it's just a basketball you're shooting, you'll get close enough that the answer is correct.
Well, that's okay.
Listen, it can't be a force.
If you're not,
See, that would be a problem because now you can't predict on that sort of micro scale. And then if you want to expand it out to this sort of universal gravitation, then you have to go to big G. But you're still using the same word.
It can't be a force, okay? It's a model killer. If it's a force, then it's something, okay, right there, causing shit, okay? You can't have it as the cause and the effect, but you can't have it as the cause, because if you have it as a force, then you have to apply limits. So you can have space-time bending and have it working everywhere, okay? You can have Pluto just right. You're not putting a time restriction on it. You're not putting a speed of light restriction on it. It's just warp fucking space. The sun's got it. Listen, the sun's got its warp space time, whatever the fuck you want to call it, to where Pluto is caught up in the fucking warp space time, and it's not applied to the speed of light. If you want to have it as a cause, you can't have it as a cause and an effect for one. But if you want to have it as a cause, it has to obey your fucking all your physics. You can't just use it whenever you want. So you can't have fucking Pluto just instantaneously fucking obeying the force of gravity, fucking, or something, light years away. That starts fucking with models, man. That starts fucking with orbits and shit. You can't have it as a cause and an effect. Okay, there's other reasons really, but this is the model reason. You can't have it as a cause and an effect. And when we're arguing with the ballers a lot, you gotta talk big G, and little g all in the same damn conversation. Like that's the trick they try and pull. I don't even know if they know they're doing it, but they try and argue big G as the cause and little g as the effect without even really knowingly doing it. They like to have it as the force and a cause and an effect. They like and it don't work like
but
that. Can't have both.
But they're two separate variables though. So why would you equivocate them? I mean,
because the same name. When someone says gravity, because when they use the word gravity, unless you're hyper Pacific, do you know which one I just invoked? I just said just one word, gravity.
That would be 9.8 meters per second. That's what I would think.
So there's the effect. Now that's the effect. And then when we ask what causes shit, you say gravity, which you're invoking big G. So it's a fucking big giant trick, Howard. It's a way to use it as a cause and an effect. Is all I'm saying.
I don't even know the value of big G. I don't know what the constant number is.
It's 1 times 10 to 6 times 10 to the 27th or some shit. It's just numbers, bro. It's arbitrary bullshit. That's why I said with my model, man, it's actual measurements and ratios.
But the thing is, Brian, these calculations are used daily and they work. It's not a.
I'm not saying they don't, bro. My shit works too. Did I prove the Earth is flat?
Your shit doesn't work. That's the difference, though.
Oh my god, dude.
What's up, Bio?
You done been through it 3 times, dude, and everybody does it and then just leaves. But anyway, here's my point. Okay, here's my point. Okay, for gravity. Okay, so 6 times 10 to the 27th. I think that's what it is, or something like that. So what is that? It's a modeling. Once you start modeling, you see how numbers work. You have an objective. Okay, they already had an objective. Okay, Newton come up with numbers, and then basically Cavendish. This is Newton was already dead, and Cavendish comes up with an experiment to make it work, and pretty much they already had the numbers because it's got to be them numbers because no other fucking numbers work. When you start modeling shit yourself, then you'll see that you just only certain numbers work. Like when I did my first model, I had to have the sun.
That's called the constant, Brian. When
I know what it's called.
Run the experiment with different amounts of variables, but you come to the same number. That's called the universal constant.
I know, bro. Check it out, though.
But you called that arbitrary earlier. It's not arbitrary.
It is arbitrary. Listen to me. Let me finish explaining real quick before you get.
You're saying the same thing. You're saying the same thing 5-6 times in a row, man. I'm just trying to add to the conversation.
Okay, well, let me say it for the 7th time for the people who haven't heard it.
Yeah,
so
maybe reality will change. Go ahead.
When I first did my refraction model, the first one I did was my first terrestrial refraction model, and I'm getting the distance and I'm applying it to the sun. And so I wanted in the North Polaris. So I got it working all the way from 1 to fucking 90. Okay, but here's the thing, and that was using 6 inches per mile squared times the percentage of the angle. But here's the thing, no other numbers worked. I had to have the sun at 3,655 feet. If I moved the motherfucker 5 feet, it broke down. It didn't work, okay? So there's specific numbers that work and don't work. Did I prove the fucking
wait.
the flat Earth once again? Did I prove the refraction of the sun with terrestrial refraction? No, I had to make a celestial refraction.
I have a clarifying question. Are you saying that it worked at arbitrary numbers for one measurement, but when you move 5 feet, that those numbers broke down?
It's all ad hoc shit. Modeling's ad hoc shit. Only certain numbers work.
I'm asking, is that what happened?
No, I'm telling you. Well, what I just told you is that only if I move the height of the sun, then yeah, the equation didn't work.
Okay, so develop a new equation, develop new variables, develop new numbers, develop a new premise to your model. That's.
I'm still working on it. It's a work in progress. But look.
Yeah. Let me finish. Good, man. That's good. You don't set out to validate necessarily your premise. You want to validate or invalidate. Either way, you make progress. So that's good.
Yeah, I agree, man. It's kind of a hobby. It's kind of fun. But the more modeling you do, the more you see that like you understand the ultraviolet catastrophe. You understand that they already knew what they needed. Okay, that's why they called it the catastrophe. Before Planck Okay, before he come up with the fucking equation, they already had an equation, and it broke down at ultraviolet light because it's
say that again.
Listen, I'm almost done, buddy.
Before they had the equation,
Hold
they
on,
had an
man. Let me
equation.
finish, man. For fuck's sake, dude.
I know, but
Anyway,
you're
they needed
literally nonstop
didn't
talking,
obey,
Brian.
so it needed more energy to get higher up the scale of light. So starting from the red, and then you add more energy, and you get the fucking the blues. Then you work your way to the white light, which is all of them combined, and then when you got ultraviolet, it broke down. So and then they already had the number. Pretty much they knew what they needed. They needed the fucking equation to fucking. They needed an equation to fucking to make it work, and they admitted it. They didn't even deny it. They did not even deny it, and that's the only model they actually admit that they just worked the numbers until it worked. But if you've modeled anything, you know that's all they've ever
you're
fucking
presenting
did.
this correctly. Something in me is hearing your words and thinking, I think you're misrepresenting something.
I know
That's
you
just
do.
my
I know you
impression.
do. I know you do. But do you think that I made up that they admitted that the shit didn't work? That they just worked the numbers until it worked?
No. If I thought that you were making something up, I would say I think you're making something up. What I said was I
that
think
was the
you're
whole point. The whole
misrepresenting
point
something.
is
That's
well, that
totally
was my
different.
main point. Maybe I should have got right to it. I should have just said, they just worked the numbers until it fucking worked. But I'm under the but after modeling shit and seeing that, that's all they've ever fucking did. Like with Big G.
So did you?
Okay? How did Newton figure out Big G without doing an experiment? Okay, he did. He worked the fucking numbers and he made it work.
Did you massage your numbers to make your refraction thing work?
What do you mean?
I don't know. I just it was your terminology. It was your terminology. I just asking you the question.
Well, I could have did it a lot faster if I'd have started off fucking with a percentage. If I'd have a percentage of the ratio. So yeah, you could say but it's not ad hoc though. Like my other model. My other model uses just whole percentages instead of 1% for every angle. I use different percentages, so that was more massage. I gotta admit, but it was kind of cheap, but it still
had
worked.
nothing to do with Big G, right? He I guess he could say he gave a value to little G, but that's everyone.
No. He's Big G, bro.
It has this accelerate. No, Big G is a universal constant. Gravitational
Yeah,
constant.
no, one time
Little G will be
27.
little G will be the rate of acceleration due to Earth's gravity.
Yeah, I know, but they give Newton the fucking credit for 6 times 10 to the fucking 27th or whatever it is.
Probably just because there's some type of derivation involved, but he didn't have anything to do with that numerical value.
That's what he used for that's what he did to modify orbital mechanics, right?
I know, but that's what I'm saying. You could probably do a derivation the same way that you could do Einstein's general relativity, where you can derive Newton. You could do all those derivations, but the exact value for the universal gravitational constant wasn't known until Cavendish, and then it's become precise. But Newton had nothing to do with that value.
Yeah, he did. He's fucking the one who came up with 6 times 10 to the fucking 27th.
If we knew that,
time, dude, are you fucking hearing me?
Brian, just real quick. If we had known that constant, then the Cavendish experiment would have never taken place, because then he would have that value for the equation to determine the mass of the Earth.
Exactly my argument in the blue marble science. What? Thank you. What? If they fucking already did, what experiment did he use?
Yeah, he used that experiment to find the gravitation.
Look it up after.
Yeah.
I tell that to Blue though. I tell that to Blue.
No,
I've told him that 100 times. I told him.
Don't change the subject, Brian.
I'm not changing the subject, bro.
You said that
you're pinned down, bro.
Oh man,
you're pinned down. You
pinned down.
Are you telling me?
You never stop talking. Stop talking for 2 seconds. Fuck, man. Brian, you said that Newton developed that numerical value, the gravitational constant. He did not. Cavendish did. That's the point.
No, Cavendish is the first to demonstrate it, to show it in an experiment. Newton is fucking. Oh my God, dude!
Big G was never.
You know please tell that to Blue Marble Science. Okay, next time you talk to him.
I'm telling it to you, Brian. I'm not talking to Blue.
Okay,
right
good. I'm with you. I'm with you. I
No,
agree.
you're
I
not
agree.
with me. Newton did
Yeah,
not
I
have
am.
Big G's numerical
No, I
value.
will guarantee you that one of them is bullshit, if not both of them.
Here, look again.
Guarantee it.
I'll say it again. Part of Cavendish's experiment was to determine what the constant numerical value was, because without that, he couldn't determine the mass of the Earth. So we had to figure that out. If Newton had that numerical value, the Cavendish experiment wouldn't exist, because then he would just calculate the mass of the Earth. Come on, man, use your brain.
Great. That's what I've been trying to tell Blue. You say whatever you want. That's what I've been trying to tell him for a long time. Trust me, Newton did not come up with Big G. I agree.
You just said he did like 5 times.
I know. That's what fucking Wikipedia says.
And Blue does not say that Newton came up with Big G.
Yeah, the fuck he does, dude.
Oh, he does. He knows where it came from.
I'll put it as far as this. He may have equations. Newton may have, like I said, you can find a derivation into Newton, probably. But the numerical value, if I gave you the variable x, and then
do not change your shit, dude. You said Newton did not come up with the fucking equation. Don't change your shit, dude.
I said not the numerical value. How many times have I used that term, numerical value? My example here,
Bro,
if I give you the variable x, if I gave you the variable x,
so now he came up with the numerical value before the experiment, right?
Oh, you dumb fuck. You dumb fuck. Listen to my words very carefully. Newton may have developed an equation with variables, such as using the letter big G. Perhaps he did. The numerical value, the constant, that number, was found and measured by Cavendish. Is that clear?
Okay, so you're agreeing with me that Newton had before fucking Cavendish. You fucking backstabbing lying sack of shit, dude. So which is it?
Brian.
Which is it?
Easy,
Did
Brian.
Newton?
Easy, Brian.
Did Newton? Yeah, I know. I need to calm down. But no, he's sitting there trying to change his shit. Like, dude, he's such a know-it-all, dude. It's hard to get along with somebody who's always got to be right. He can never ever be wrong, dude. Like if right now you showed me a page that said that Cavendish invented Big G, or I'd say, man, you know what? You're right. I stand corrected. Bowden would never do that, dude. He's never wrong. He can't be wrong. You just changed your story mid-fucking sentence, dude. You just changed your story mid-sentence. What I said is Cavendish did the experiment, okay, but they already had the numbers. Newton came up with the numbers.
Didn't have the numbers.
And you said, no, Newton didn't come up with big G. You said Newton came up with little G. You said Newton come up with little G, not big G.
Not the numerical value for big G. Not until Cavendish.
Did you not say that Newton didn't come up with big G, come up with little G?
I said he may have had the variable big G, but he did not have the numerical value to go along with that constant. Cavendish measured that numerical value. Fuck, man.
So you didn't say that that Newton didn't come up with big G, right? And Howard, you didn't say that either, did you? Hold on, both of you. Howard, did you say that?
He did not know the numerical value for big G. He may have used big G as a variable within an equation, but the numerical value that it represents, he did not have.
Okay, but is he accredited to big G? Yes or no?
It depends on how you want to say it, man.
It's a yes or no. Is he accredited with big G?
No, it isn't. It's not a yes or no, because he can plug in the equation with big G, but if you don't know the numerical value, that constant value, then I would not say he's not. He should not be accredited with big G if he doesn't know the constant value. That's what I said. Also,
I agree. But is he accredited with big G?
Oh, the history? I don't give a shit. He probably is.
So you just obfuscated the whole point. So now we got to go all the way back to the beginning. Okay, what I told you was that he come up with a number. He didn't do the Cavendish experiment. Cavendish did an experiment because he knew the numbers he needed. He come up with an experiment. Dude, I guarantee you, I appreciate what they've done. He done a lot of work, dude. He gave that. It's a good model. I ain't totally knocking the shit. I'm just saying it's all fucking numbers and modeling. It doesn't prove nothing. Was my whole point from the beginning. Okay,
it does.
That's my whole point.
You can run the experiment and you can measure the same constant. So it does, yeah. It does validate something.
You know how many variables you got to get just right, though, dude? You know, you got to say, oh, this and then that.
It doesn't have
But,
to be
man,
crazy precise. If the question is, does it exist? You don't have to be that precise, to be honest.
Anyway, though, man, hey, don't go nowhere, man. I'll be back in like 3 or 4 minutes, man. Y'all try and stick around if you can.
Maybe not. But yeah, that's the funny thing with all this, is that you don't really have to be that precise. If you want to be that precise, you're already acknowledging that it exists, and you're just trying to measure, you know, its particular value. That's when you're that precise. If you just want to ask or answer the question, does it exist? Yeah, you do whatever the fuck you want. Use different size masses. You'll see a different amount of effect. Wham bam boozle. Flat Earth's arguments are so polarized that it's easy to shut them down. Create some nuance within it. How was your Christmas, Howard?
The point is, though, man, is I'm going to agree. Technically, I'm going to agree with you, though. I'm going to say that, yeah, that John Michelle and Cavendish are the ones who who come up with it, okay? Which wasn't demonstrated until like fuck. I think it was oh man, I think it's 1900. Oh my god, dude, I forgot. But it's like about, you know, a dozen or so years after Newton and all that shit, you know. So when they try and say that Big G, there's a reason why they attribute that shit to Newton. But like I said, I've made videos about this, multiple videos. Until you've demonstrated it or did at least some kind of experiment, like Cavendish and John Michelle. See, Coulomb, that's what it was. It was like in 1880 or some shit, or 1886 or 7. And Cavendish wasn't until 1898 or some shit. It was like years after. But they try to say no. Big G came before Coulomb's law. Okay, and I'm telling Blue that
I'm not sure. I don't know which one came first. I don't know.
It didn't. He's saying that Newton calculated Big G, and it most certainly was before Coulomb's law. But as far as the demonstration, the actual calculation, the experiment, Coulomb's was way before Cavendish and John Michelle.
Totally possible. I don't know. I don't know the dates on that. The history part of it is uninteresting to me. I do know Coulomb's law, the equation, and then the gravity. I know that those equations are like almost the same, almost the exact same. But other than that, I don't know which one came first. It's uninteresting to me.
Yeah, they're close. So one of them's for the for electrostatics or whatever, for 1 Coulomb is compared to 1 Newton. And it's more powerful. But supposedly when you get to the scale of planets and galaxies especially and all that, the gravitation, like it doesn't scale the same as the electromagnetism or electrostatics or whatever. It scales differently. So at a small rate, like at a microscopic level, it doesn't factor in at all in quantum. But then on a planetary scale, it like dominates the electromagnetism or whatever. That's, to my understanding, that's what the way mainstream has it.
Something like that. It's something like that. It's like the quantum and the universal level. The equation that we have for gravity seem to not be accurate, but they're perfectly usable for our local scales. But yeah, quantum and universal, that's the tricky part. If that could be figured out, then there would be a grand unified theory in physics, but there isn't, so the pursuit continues.
But so anyway, I think that the actual story is that Newton come up with 6 times 10 to the 27th, but Cavendish did the experiment which weighed the mass of the Earth to come up with, to basically justify the calculation. And dude, when you read it, man, they're kind of discreet a little bit about it, but they can't give multiple dates for one thing. And to me, I go by when was the experiment done, But when you look into it, dude, you're like, the mass of the fucking Earth. But in my opinion, he already had the number he needed. That doesn't take away from what he done, dude. Like I said, if you start trying to do modeling and shit, you see, dude, you appreciate the fucking time and how smart these motherfuckers were when you see how long it'll take you to do something. And you know that they did something 50,000 times harder and probably 20 times quicker. You know what I'm saying? You appreciate these motherfuckers' skills, like Newton.
Yeah, that's the whole thing of standing on the shoulders of giants before us. That's that whole thing. But flat Earth has an opposite viewpoint of that. It's that we should ditch all that.
Well, it doesn't prove it. The point is, it doesn't. Once you start adding any variables at all, without showing them, to me, it's just suspect. Some of the shit might be dead ass true. Some of it isn't.
That's my opinion.
You just have to invalidate it with an experiment.
Yeah. Well, it's got to be validated first with experiment, right?
Well, I was in a bad spot. I didn't hear you. What?
I think the shit's got to be validated. I think whatever is claimed as fact, is my opinion now, should be demonstrated, should be empirical, falsifiable, demonstratable. That's my opinion. If it's not, then it's not 100% fact or whatever percent fact.
No, of course not. If you run the same experiment that other people did with the same methodology and same materials, and you come to a different answer, then you have possibly invalidated something. But that's the process.
Let's say this.
Using the phrase "nuh-uh" or "I don't think so." I mean,
for the sake of fucking of going out there, just follow me out one time off the reservation one time. So let's just say that Coulomb's law, doesn't quite work with the it's similar to Big G, but it doesn't work with orbital mechanics. It doesn't quite line up with relativity, whatever. But we put a variable in, like the strings, the filaments that tie the stars together or something, or tie the planets together. And let's just say you come up with a model where electrostatics or electricity, where you really only need like one force with a positive and a negative variable to it, just like electricity or electrostatics or something. And you just model like the electric universe guys have done. It's a different kind of math. And so all the predictions lately for gravitational shit's been wrong. And electric universe has been able to get all these predictions right. Predictions made by what you call it. God, what's his name? Who Walt Thornhill.
They haven't. I've seen the website that Grimm occasionally will post. He doesn't often. But it's a website that's listing predictions the electric universe made. They claim dates. When you look into those dates, no, I know. When you look into those dates, they're not correct. What they're normally posting is some type of news article that has.
No, they get about 2 or 3 a year, bro. They've got they still got a list of predictions still out there.
I know. I'm almost done. So I've looked into about 3 or 4 of them on that website. It's normally news articles explaining it in layman's terms, but those experiments and observations were done 5-6 years before any type of electric universe prediction. They're just seeing the results of something and tying it to an electric universe, and then they're placing a date on that prediction. Yeah,
I'll give you that.
They're not predicting anything.
That with some of it.
Yeah, they're not predicting anything.
Made predictions. Trust me, they have made predictions recently, but they did do that to like saying like our model predicts something that's already happened. They did do that, but they have also made predictions like with the latest discoveries and shit. There's a few of them that they have predicted. But yeah, I will say that. Don't put them all in one box like all of them are post predictions. Because they ain't all post predictions.
100% of the ones that I've looked up have been, and then I just gave up and got really tired of it. So I won't say all of them because I haven't looked at all of them, but I'm batting 1,000 so far. As far as it's not a prediction, it's an explanation.
Joking, dude. See, when I'm talking to you, I think you're being rational, and then you say something like that, dude, which is fucking asinine, dude. So you're gonna say, I'm just telling you that they're making predictions, whether you believe me or not, dude. I'm giving you the fact that yeah, some of them are post predictions, but I'm telling you like recent discoveries, like shit that I don't even agree with. Okay,
I agree.
And I'm just telling you what the fuck they wrote down. Okay, and looking at previous videos, and I look at previous videos to what they predicted, and then fucking look at what the data shows. And fucking and all of a sudden you're batting 1,000. Like they made no predictions at all, bro. You just go out on a limb where they made no predictions at all.
I don't think they have. What I'm saying is, I agree that they claim that they're making predictions.
Dude, that's why I feel like I'm talking to a fucking donkey, dude. I get where
you're not because you're the only one talking. You're the only one talking.
I know it all, donkey, dude. It's like talking, dude. You need to work on this, bro. You're a smart guy and all that,
back and forth.
I have no problem with your worldview. It's like talking to a know-it-all donkey, dude.
You're talking to a brick wall right now because you're the only one talking. If you want to talk to a person, you're gonna have to listen at some point. What I'm gonna say is
just
that
trying to say you gotta, dude. Nobody likes a know-it-all, bro. You gotta quit being a mule.
Okay, you done?
A donkey is better put, bro. A total donkey. Because a brick wall, at least doesn't have.
Here we go. Are you done? Hope you're done. I understand that they're making claims that they're making predictions. Yes, I agree. That's what they're claiming as predictions. I went to their website where they list a number of these predictions that they claim, and then I investigated. I believe it was 4 of them. The first 4. And I found that they were not predictions. They were after the fact explanations. I then gave up and said, if I'm going to bat 1,000, I better quit while I'm ahead. But it was 4 for 4. If you really want me to look at 20 of them, perhaps at some point I will. Oh, no, he's gone. Never mind. Spiral, and then leave. Cool. Sure, I'll have the same conversation in 20 minutes.
Quiet as a mouse. What's up, Gil? Graphics, man. You're not gonna put the groceries in the fridge, babe? Forgot. Here, you put the food up, huh? Oh, right? Okay, yeah, yeah. What you doing, man? Yeah, of course. I love that smell. He's like, mm. Yeah, it's like Google Earth. I was like, huh? One day, that's what I meant. The house wasn't even there. I was like, oh, Google Earth. We built it 2 years ago. Must be really that's crazy. Oh. Oh, Gio, I got something I'll drop for you in the live stream. I know you can't talk, but there's a link. It might, you're probably gonna like watching this. The title is Solar Gamma Rays. Dark Matter is the duct tape of bad science. Full of duct tape on that model.